And so we start a new series or course or whatever you want to call it. Today we're going to get started on a inventory system. And for an inventory system, you're going to need to get started with items, which is what we're going to be talking about today. But unlike the previous couple of courses that I've made, this one's probably going to be a little bit shorter as well. I'm going to upload a per episode project file for the progress, so you can see everything that we've just made so far. The next episode, everything that we've just made up until then, and then up until the very last one. Just wanted to get that out of the way. So let's talk about inventory systems and items. What we're going to be doing today is we're going to be making the blueprints for our items. And I mean that in both making actual blueprints and also making the basics that we're going to need to build upon. So let's get started making items. We can do this in two different ways, and this is a very important distinction early on. A lot of people will want you to make, here in the miscellaneous tab, here a data table, which you can do, and that's perfectly fine, having all of your items in a data table. I don't personally love that, and I'll explain to you why in a second. But I'll just show you real quick how we can go through and make a data table based system. We're not going to be moving forward using that, but it's pretty easy to substitute things in and out if you're using data tables instead of data assets, which is what we're going to be using in the end. So for a data table, what you want is you want to come up here to blueprints first, and you're going to make a structure here, and we'll call that item info. And in that item info, we will just put in everything that we need. So that will be something like a name for the item. That'll be a string, and add a couple more variables. Maybe you want a item ID in case that becomes relevant for whatever systems you're using. We want a icon, which we can use a texture 2D for. And then we might also want a mesh for it as well, for if we spawn it inside the world. So for that we can just use a static mesh. And the last one, let's call that a value that we can use for buying and selling it. So this is how we can set up a structure to hold our item info, and then we can make a data table based on this structure. Now there's a couple of issues with this method that I personally don't like. So let's make that data table and just call it items. And if we start making new entries, we can see it has all of the information in there that we put into that structure. So that works, but there's a few little issues here. Mainly that being, this is a data table and it has a bunch of hard references in it. So if we go back into this, you can see that this static mesh, and I also believe this texture 2D, are hard object references, meaning that whenever this data table is getting loaded, it will also load in everything that it's referencing. And if you have hundreds up to even thousands of items, all the meshes and textures for them are going to get instantly loaded the moment you look anything up into the data table whatsoever, and it's going to take up a huge amount of memory. We don't want that. You can change that by, instead of using a object reference, changing this to soft object references, and then you have to manually load those assets in when you actually want to use them, but they don't always get loaded into memory. So there is a workaround for that issue if you really want to use data tables. I just wanted to offer up that possibility for you to use data tables if your system might benefit from having data tables. If you have a whole bunch of items, like a lot of them, it might actually be worth it to use data tables because it's a little bit easier to manage than having a bunch of different separate assets. But let's take a look at a data asset based system instead. So we're going to delete this because I want to show you the other much more important reason as to why I like a data asset based system more. So let's make a blueprint class here. And in the classes, we're going to be looking for the primary data assets. And this is going to be our blueprint for our just general item data assets. And here we can put in some functions that do some simple calculations, which is kind of nice if you want to like bake in some calculations as to pricing for like selling and buying items. So here in the BP item, if we make a new function and we call this get sell price, what we can do is we can just, in this case, very simply, we add a return node, and that return node is just going to return the value of our item divided by, let's say, 2. So it's half the price that we get for selling. This is a very simple function that doesn't really do much, but of course you can do a lot more complicated math here if you wanted to. That's one upside of using data assets. The other upside we'll get to in a moment. Let's add in the same variables that we had in that item data. And for this, you can also use soft references, by the way, just like I showed you as a solution for the date table a moment ago. Since we're not going to be loading in every item in the game whenever we refer to a specific item, it's much less of a problem if we load in all of the refer to assets. So you can get away with using hard references a little bit easier with this data assets based system. You still really should be using soft references in most cases whenever you can, but this does make it a little bit less of a headache to manage loading in and out assets. And we're going to set all of these to being exposed. So now that we have this, we have the basic setup for an item. And now that we have that, we can go into our miscellaneous tab here and we can make a data asset. And we can make a data asset based on the BP item class that we've just made. And this is now a asset that takes that BP item as a sort of template. So let's call this something like item underscore rock. And when we open that up, we can see it has all of the information that we put into it. So we can say this is the item rock, the item ID. We're probably not actually going to be using an item ID for this system, but for a lot of systems it can be useful to compare if two items are the same based on ID rather than on name, because it's a quicker operation to compare two integers than comparing two strings. Then for an icon, we can put in a texture, which I don't have any textures at the moment. I'll get some in the future. And then for the model, do we like have rocks? Static mesh rock. It's a pretty good rock for our purposes. And then its value will be like 2 gold or something, right? And now we have an item. Now, we can't put this item into the world because it's a asset itself. It's not like a blueprint class. So this doesn't directly exist within the world. And in order to do that, we're going to make a specific blueprint class as well. And that is going to be just a normal actor. And we'll call this BP world item. And this world item is going to have a variable here. And this is going to be the item data asset. So this will just be a value of whatever kind of item that we're displaying here. And then we can choose that as the BP item. And in this case, we want that to be a object reference. So from there, we can choose any data asset that is based off of BP item. So we can say data asset rock in this case. And we can simply add a static mesh here. And in the construction script, we can set that static mesh with the set static mesh node to whatever our item data asset is. So we want to make sure that the item data asset is valid, so that it's actually like pointing to something. If this value is empty, we don't want to do anything. But if it is valid, what we want to do is we want to get the model. And that's then going to be our item that's going to get displayed. So this is the way we can display items in the world. So now we have a world item class that we can drag in, and this can now function as a item. And as such, we can use this with like line tracers or collision to then pick up that item. And if we have eventually got an inventory for ourselves, we can then add that to the inventory as such. So now we can place the items in the world as well. Before we end off here in the first part about items, I do want to show you one more important thing, which is the main reason that I decided to go with a data assets based system. And that is, right now we have just a general item. And that's fine, but since we're using data assets instead of throwing everything into a data table, we can actually make use of class inheritance. Meaning that we can make children of this BP item, which is the template that we're using for our data assets, to make more specific items. So what we can do is we can create a blueprint child of this. And this will be, for instance, BP item, and let's call this weapon. This will have all the values that the other one already had that we gave it, but we can give it some new values. So this can have a value for damage on it, for instance. And if you have a very in-depth RPG system, you can put something like a element on this. so that you can use that in your damage calculations. If you have like a fire weapon and you're attacking a water monster, you're dealing less damage, you can put that information on here as well. And much the same way, a lot of like the damage calculation stuff, if you want to, you can also put inside a function on these data assets. And let's also make sure that we expose this. So now we can make a new in miscellaneous data asset, and we can look for a weapon. So BP item weapon, and we can make our item sword. And if we open that up, we get all of the same stuff that we just had in here. But going into our BP world item, for instance here, right? We have this item data assets variable. And there we could choose the item rock because it was a data asset made based off of the BP item. But we can also choose any data asset that is made on a template that is a child of BP item. So now we can use this inheritance structure to check for certain types of items. So we can have this item split off into food items and armor items and weapon items and whatever. And they can all have some unique functionality and some unique values to them that the other types don't have. But the main inventory system is all still going to easily be able to treat them as items. And then when those specific properties become relevant, like when you equip a sword, that is then when those values actually do get used. That is something that a data table-based system would have a lot more trouble with. Of course, if you really do want a data table-based system, there's workarounds to get that to work. I prefer using a data asset-based system if you're making a game that doesn't have thousands upon thousands of items. Anyway, that'll be it for now. We've made the basics for items. There will be a link down below in the description for the Patreons and YouTube members to download the project so far, and next time we will be moving on with our inventory system. In the first part of this series, we started making our system to handle items. So we made some data assets to represent normal items, and we also made a data asset type to represent specifically weapons. And you can do whatever you want with this and make like food items and whatever. Today we're going to actually implement that into a inventory system, at least the beginnings of one. It's actually going to be remarkably simple. So let's get started on that. And the first thing we're going to do is I'm going to go into my actual character now. And on the character, we're going to be adding a component, because the inventory we're going to be making is going to be in components that we can add to any actor that we want. So that way we can add inventories to things like enemies. So we can use those as things like drop tables, potentially. Or we can add inventories to shops. So the shops actually have an inventory and they will run out of items, so you can't infinitely keep buying things and so on and so forth. And then those inventories could restock. You could make interesting systems where NPCs trade with each other and their inventories are fully dynamic. If you can think of it, you can do it with a flexible system like this. So this is going to be really quite cool. Let's get started by making that component though. So I'm going to go back into the root of the project here. We're going to make a blueprint class, which will be an actor component. Not a scene component, a actor component. Because a scene component is a component that has a transform, a physical location in the world. An actor component is a component that just will hold some data for us. So this will be our BP inventory component. And the inventory component for the time being is going to just hold a couple of values. We're going to add some functions to it as well in a moment, but for right now, let's get started with a variable, and that will just be our inventory size, which we will make a integer for obvious reasons. Let's also expose it and set the default inventory size to something like 16. Now we're going to need to hold a item, and the way we're going to do that is through referencing those data assets. But I'm going to make a structure to hold that first, and I'll show you why in a second. So go up here to Blueprint, and we'll make a structure, and in that we will call this str for structure inventory slot. In the inventory slot, we're going to add a couple of bits of data. I personally like having a bool in here to let us know whether or not there is an item here. So if we're looking through our inventory, we don't need to actually look, is there a data asset? We don't need to look how many items are there in the slot. We can just look at the bool and say, hey, does this slot contain an item at the moment or not? So we'll just call this has item. Then the next variable is going to be our stack size. Some items you might want to be able to stack up higher than others. If in your game everything is going to stack up infinitely, or going to stack up to like 999 or just 99, or like for Minecraft purposes 64, stuff like that, you don't really need this. But for a lot of games it could be useful to have a stack size. And we'll go back into the item data asset in a moment and add the stack size per item as well, because this is going to get filled in by the item itself. And then adding in one more variable, this is going to be the item assets, which will be a BP item object reference. So now that we have this structure, we can go back into our inventory components and add that as a variable. So let's call this the inventory. And the type will be our structure inventory slots. For now, let's also expose that real quick. By default, it's just going to be a normal variable, which has one value. So we can say, hey, does this inventory, which is one large, have an item? What is going to be its stack size? And what item is in this slot? Now, if we come up here and we change this into an array instead, we get multiple item slots that we can populate like this. So that's quite neat. Now, unlike actors, components don't have a construction script. So we can't make a true construction script in which we set up the construction for this component. What we're going to do instead is we're going to make a function and we'll just call this component construction, or let's call this inventory constructor, just so that we know what this is like. And then we can either run this in the construction script of whatever actor that we're working with, or we can just run this on begin play, potentially both. And what we'll do is we'll get our inventory array here, and we will get our inventory size. And what we're going to do is we're going to add an entry into this array for how many inventory slots that we have. So we can do that with a for loop. So a normal for loop, not a for each loop. And then the first index is going to be, in our case, let's say, it's easiest to keep this at 0, and our inventory size, this is quite important just as a general programming thing, because we're starting at first index 0. If we're going to go up to 16, that actually gives us 17 slots. So what you could do is you could say start at index 1, that works, or what you could do is we're going to go up to our inventory size -1. And then in the loop of that body, all that we will do is we will add just a new slot. It can be empty, doesn't really need to have anything put into it. We just want to make a new empty slot. We also, though, want to make sure that we're not adding any more slots than is altogether necessary. So we should also clear the array before we start this up. Do be aware, though, that if you run this function, that does mean that you're going to clean out your inventory. If you run this function for any reason while there's items in the inventory, it's going to remove all of those items. It's going to just delete them. Since we're only going to be running this at construction or at begin play when there's no items in the inventory yet, it doesn't really matter. If you call this during gameplay at some other time, do be aware that you only call it if you have your current inventory stashed and saved somewhere safe, so you can reload that data back in after whatever you've done. Generally just better to avoid using this function during gameplay altogether. Now, on begin play, we'll just run the inventory constructor. And now if we go into our third person character, we can just add our inventory component, in which we can see our inventory size is 16. And if I just simply start up the game here, and I go into my character here, open up my inventory components, we will see that the inventory now has 16 slots that we can work with. They're all empty though, so they all have no item. Stack size is going to be 0, and our item asset in this slot is nothing because they're all empty. An alternative way to do it is not to call this in begin play, but instead what we could do is we could call this on construction in our character instead. If you do it this way, you will have to call it on construction in every single character that you're working with. So that can be a little bit bothersome, but it also can be a little bit more flexible. So we can say inventory constructor runs on construction. The big upside of which is if we take, in this case, our third-person character, the idea would be that this, for instance, would be an enemy that has an inventory that will drop upon death. If you just drag this into the map here, and you go into the inventory component, even before begin play starts, we already have access to the inventory slots now, and we can populate them however we want. Once again, do be aware if you have this with running it in the constructor, it will get overwritten if you also run this at begin play. So you probably don't want to do that if you plan on populating inventories like this in the world through the viewport. Generally speaking, this is what I personally like best. And this still functions more or less the same way for the player, if all goes well, because if I go in here now and I go into the inventory component, I still have my 16 inventory slots because the player gets spawned in on construction runs and I get my inventory slots that are all empty. Oh, and one more option that we could do instead of calling it through another construction script or at begin play is we can do this inventory constructor. We can set this to be a call in editor function, and what that will allow us to do is if we have an actor that we don't want to call this on begin play or on a construction script for whatever reason, construction scripts tend to rerun when you move characters, which would clean out the inventory, which would be really annoying. So if you just drag a character or whatever into your scene and you go into the inventory component, we now have a button here that says inventory constructor, and when I click on that, it generates the inventory slots just like that. Okay, so now that we have a basic setup for our inventory component, we probably should wrap up here. But next time what we're going to do is we're going to program in the functionality for adding and removing items to that inventory component, because that is quite complex in and of itself. Because what we need to do is we need to check whether or not we have empty space in our inventory to begin with, and if we don't, we need to not add the item, and if we do, we need to add the item. But then if we have a inventory slot that already has the item that we're trying to pick up, it should probably add it to the stack rather than in a new inventory slot. And it's all like, there's quite a bit to it, and I think we should probably push that off into its own video next time. So as always, the link down below in the description to the Patreon, and for YouTube members, you can download the project so far to your liking to play around with and see how everything works. And next time we'll be back with a new updated project for you to check out. So last time when we left off, we had a start for a inventory component and we could populate it with empty slots, but we couldn't actually add any items into those slots, which is kind of the point of an inventory. So today we're going to be doing something to both add and remove items from our inventory to actually make our inventory function. It's quite important. So on our BP inventory components, we're going to be making two new functions. The first one will be add item. And then we're also going to be making one for remove item. We'll get started with the add item first. So what we want to do here is we want to check whether or not our inventory has the item that we're trying to add already. Then we're going to check whether or not that item slot specifically has enough room to add something to the stack. If it does, it's going to add it to the stack. If it doesn't, it's going to keep looking for the next stack that it can add something to. If it goes through the entire inventory, doesn't find the stack, then it's going to find the first empty inventory slot and it's just going to add it to that. That's the basic logic that we're going to be working with here. So we're going to need our inventory here, and with that we'll add a for each loop with break, because we wanted to stop once we have found something that does what we need it to do. For our function input, we're also going to want to set a BP item object reference for the item to add, because we want to know what item we should be adding. So for every single inventory slot, what we're going to be doing is we're going to break the structure apart, and we're going to check whether or not the item we're trying to add is equal to the item that already exists in that. Now, if you want to be a little bit more optimal about this, we first check whether or not there's even an item in that slot, because if there is no item in the slot to begin with, we don't need to do this comparison, and it can save us a negligible amount of computing power, but a theoretically existent amount of computing power. So first we're going to check, does it have an item to begin with? If it does have an item, is that item equal to the item that we're trying to add? If it is equal to the amount that we're trying to add, then we're going to need to check stack sizes. And we haven't really implemented any code or variables to deal with this on the item itself. So I'm going to open up my BP item, which is the blueprint that the data assets are based off. And I'm going to add a new variable here, and we'll just call this stack size. And we'll set the default value to 64 here. I did a little playing about before starting recording, so a lot of these values are still apparently in memory. So then we check whether or not the current stack size that we have, which is the amount of items currently in this slot, is less than the amount of items of this type that are allowed to be stacked. So let's get the item to add, and there we can get the stack size. You probably should actually call this max stack size instead, just to be clear about what this value is going to be used for. And only if the current items in this slot are also less than the maximum amount of this type allowed in one slot, so we can also make an extra branch for that, only then do we add to this. So at that point, we get another reference to our array, and we simply set our array element, and we're going to be making a structure here. So first and foremost, we obviously want this to have an item. And our new stack size is going to be equal to our current stack size plus 1. Now, this will only allow you to add one item at a time. So things like merging item slots is going to be a little bit more difficult. And that's honestly also going to be a little bit more complex. So maybe at some point down the line, we'll come back to this function and upgrade it to where it will be able to take in multiple items at a time. But for now, I think that this kind of suffices. The easiest way to deal with doing multiple items at a time is just running this function a set number of times rapidly after each other. It's not exactly efficient, but it'll probably do. And then the item asset to add will of course be our input item to add. We will set that to the array element index of whatever index our for each loop is on. So it's just overwriting a slot that already exists. And that is how we add a item if it already existed in our inventory. Now we can simplify this a little bit because now we have 3 branch nodes back to back to back. That's not really all that useful. So what we can do instead is we can make a AND Boolean node here and we can just check for all 3 conditions at the same time, which is just a little bit easier to work with. If you are a Patreon or a YouTube member, you will be able to download this project file on each episode with the current progress to keep along with whatever we are doing. So that's just a little bit cleaner. And after we've added that item, we're going to want to break out of our loop. And for this, I'm actually immediately going to be adding rerousing nodes because having lines that loop back around can be very confusing otherwise. Because otherwise it's going to keep looking for the next slot. Now, if it doesn't find anything at all here, where it can add to an existing stack, at that point we're going to do a second for each loop that's going to look for an empty slot to put this in. But we need to check whether or not something succeeded here before we do that for each loop. So what we'll do is we will make a local variable. Local variables are variables that only exist within the context of a function. So has found slots, we'll call this. And every time we run this function, this variable is going to have a fresh value of whatever you set the default to, in this case, false. So if we find something, we're going to set this has found slot to being true, so that we know that we have found the slot and we've done the thing. So we don't need to do the next for each loop. So after we complete this for each loop, what we'll do is we'll put in a branching node here, and we'll check whether or not the slot has been found to begin with. If that is true, we can simply add a return node to end this function, and we'll return the value of has found slots. That way, when we run this function, we'll also be able to tell whether or not something was added to the inventory or not, because if the inventory was full, it's not going to add anything, but it could be useful to have that information to display to the player like, hey, your inventory is full. Stop trying to add things. Now, if it hasn't already found a slot, we're going to check whether or not we want to maybe get an empty slot. So we're going to do another for each loop over the inventory. We're going to, again, break this structure. And this time we're just going to be checking has item. So we'll check that. And if has item is false, then we just add 1 to that slot. So there's a lot of checking of other stuff here. That doesn't matter. If has item is false, there's nothing in that slot. And we can simply set whatever we want in that slot without doing any more checks. So we can just copy over the set array element here. We can copy over the make structure inventory slot as well. Put that into the set array element. We're going to set this to has item being true. The stack size is always going to be 1 if we add it through this method, because we're looking for an empty slot. And when we're adding something to an empty slot, we're always going to have 1 of that item. And again, the item asset will be whatever our input was in our function here. And we'll only run this again if this branch is false. And then once again, we're going to be setting has found slot to being true, because we've now found a slot to put this thing in. And after that, we're going to break this for each loop, because again, otherwise it will start adding it to every empty slot. And we only wanted to add it to the first empty slot that we have. And once that has been completed, we add a return node again, and that return node is just going to return the value of has found slots. Do be sure to hook up the set array element index to the array index of the for each loop for the second one as well. If you don't do that, you run into an issue where it just keeps overriding the first slot of your inventory. This is the function for adding items to our inventory system. Now, this is a little much. If we're going to remove items, it's going to be much easier. Because what we do when we want to remove an item, we can do this in a couple of different ways. We can also try to remove an item based on the item itself, and do something similar that we did for adding items. That has its merits. For the most part, what I prefer to do is, since we already have all of the information in our inventory, we just need to look up what item slot that we're referring to and just remove 1 from that item slot. So when you have an array, what you can do is you can just find an item, and we can just pass in the item to find, and this will just find the array index that is equal to whatever structure we put in here. So if we already have access to our inventory anyway, and we're selecting, hey, this inventory slot, we want to remove an item from it, we can just pass that into this find function and save ourselves a lot of headache. So after we found that, we can get a reference to it. This is quite relevant that we want to get a reference and not a copy, because if we make a copy, we're going to not actually change the inventory slot. You want to directly have a reference. And in that reference, what we're going to do, we'll check whether or not the stack size is greater than 1. Because if it is greater than 1, we're just going to subtract 1 from it. If it is 1, we're going to remove the item from the inventory altogether. So we'll check whether or not this is greater than 1. And we'll do that in a branching node. And that's actually the first execution pin that we have here. If it is greater than 1, all that we need to do is get this stack size and say, hey, decrement integer. And that will do what it needs to do. If it is not greater than 1, which means that it is 1 or less than 1 if you somehow glitched the game, we're not going to worry about that for the time being. What we'll just do is we will set by reference variable, and then we're going to be making a new structure that we're going to set the value as, which we'll also need to do for the decrementing int in a moment. But we just want to set this to having no items, having no stack size, and having no item reference at all. And for the true version of this, what we want to do is we want to have it as an item. We want to set it to its new stack size, and we want to take out the item asset that we already had. And the reference that we're setting is going to be the thing that we got from the get reference node. So what we're doing here is we have the inventory, we find the index, we get the reference, and then we're setting that reference again with new value. So this is how you set up the simple setup for removing items from the inventory. It's actually quite simple. And then in both cases, we're just going to put this into a return node as well. And here we don't really need to return a bool whether or not it was successful removing the item from the inventory, because removing the item from the inventory is probably always going to be a success. Now, for testing purposes, we want to test whether or not this works, but we don't have any code to add items to the inventory yet. We'll do that in the next video. For now, we're just going to make a new extra function, and we'll just call this something like add rock, and we'll simply run the add item function that we have here, and we will just add a item rock. And we'll make this call in editor, so we can just press the button in editor a lot until we get to a point where we start filling up our inventory entirely with rocks. Now, if we run this, we can go into our inventory component. Now we have add rock and inventory constructor. We need to construct the inventory first. I will open up a couple of item slots here, and if I add a rock, you can see the first slot now has an item, stack size 1, item rock, and I can keep adding rocks to it. And we can go up and up and up and up and up and up until our stack size is entirely full. And now we can see we are approaching a full inventory slot, and we've got a full inventory slot. If I add one more now, it should start populating the next inventory slot, and it does. So we have a functioning inventory slot system. There's still a lot of work to be done. Next time we're going to make a little bit of a simpler video on actually picking up items, and I'll probably throw in a little bit of a bonus. We'll also make a chest that can drop items in the world or something like that. And after that, we finally are going to get to implementing this in a UI, because at this point we still don't have any UI for this. This is all just on a technical level, like the code works, but players need to be able to interact with it. So still a lot of work to do, but for now, if you want this project file with everything up until now working as it is, there's a link down below in the description to the Patreon and for YouTube members to download it, and you also are supporting the channel if you do that. So thank you very much for watching, and I'll see you back next time with some more cool stuff. We have items, we have an inventory to put them in, we have a method to put them into the inventory, but we have no method to pick them up yet. So let's talk about that today. It's going to be a quite simple and straightforward way to do it. If you've seen my video on blueprint interfaces and the basic interaction system that I built with that, that's pretty much what we're going to be doing here today. So that way we have, number one, an interaction system built for the game as it is, and number two, we can also immediately easily implement something like a chest, which would be quite nice. So what we'll do is we will start off by going into our blueprints, and we want to make a blueprint interface here, which we'll call BPI interaction. We can just call it BPI interaction, that's fine. The first function that we're going to be adding here is on interacted, which should have a input of a actor, object reference, of course, and this is going to be the interacting actor. So this will be the actor that is doing the interacting, rather than the actor that is getting interacted with. That can be really quite useful. And then the output of this is going to be a bool, interaction finished. We want to check whether or not the interaction we had is successful. For this case, we're going to be adding items to the inventory. If the adding of the item to the inventory doesn't work out for us, we want to be able to send that message back to the player so that the player can do something with that. Now, as you might be able to tell, we are passing in a generic actor reference rather than a specific player reference. And that is because at this point, I don't know if there might be enemies that also want to be able to interact with items and pick them up in our game, right? And I just want any generic actor to be able to interact with this. How are we going to do that? Well, the way we're going to do that is in our interaction system, we're also going to add a second function, and that is just simply going to be get inventory. And this very simply just outputs the inventory. So that will be the inventory component that we have made. So now we have this BP item, which is the blueprint for the data assets that the actual items are referring to. We're not going to be using this because these can't exist in the world, as you remember. If I try to drag these out, like we can't interact with these because these are not actors. Same with the BP item weapon. What we want to do is we want to get the BP world item, which is the actor that can exist in the world that represents the items. And that is where we're going to be implementing these interfaces. So in this one, we're going to go into the class settings and we want to check implementable interfaces. We check for our BPI interaction, and that immediately adds the interface tab here with get inventory and get interacted. And in our overrideable functions, those should also now be added in. This one is going to implement the on interact. So whenever this item gets interacted with, it's going to try to add itself to whatever inventory interacted with it. So let's open this up. It makes us a function for this, and this is actually quite simple. We get a reference to whatever actor interacted with us, because that is what we set up, and whenever an actor interacts with this, we have to pass through that reference. But because we also made a function in that interface to send through an inventory component without needing to know what type of actor this is, we don't need to cast to the player. So this is now a lot more flexible in what we can actually do with it. If we want to have enemies be able to pick up weapons or any item for that matter, we still can do that. They just have to implement that same interface. It's actually quite simple. So we can simply get inventory, and that will return us the inventory of whatever actor is trying to interact with this item. Now, we need to check whether or not this is valid to be sure, because if something that doesn't have an implementation for get inventory is trying to interact with this, that could crash the game otherwise. So if this is valid though, we're just simply going to try to add this to that inventory. So if we get this inventory, we can just say add item, and only if valid is true, we will try to add that item. And the item to add will just be our item data asset in here. So we can just drag that over in there. And now we need to check, okay, so if it actually added the item into the inventory, we also want to destroy the item that's on the floor. Otherwise, we can infinitely keep picking it up, and we don't necessarily want that. So we'll add in a branching node here. And if this is true, added item, then we want to simply destroy actor, and we want to destroy ourselves. If this is false, we just want to get immediately back to the return node. The value for the return will also be the same as whether or not the item was added to the inventory. This can just be generally useful information to have, because if this is false, for instance, if an AI is trying to add something to its inventory, it will be able to see, hey, nothing was added to my inventory, I probably should go like back to base and deposit some item and try again. Something like that. You can program that in. For now though, this is all that it takes to make an item be able to be picked up. Now, in the third-person character itself, which is our player character, we need to implement that same interface as well. So we're going to go into class settings, we'll check for BPI interaction, and here we need to, we don't need to implement on interacted, really. We want to just implement get inventory, and get inventory is simply going to just return a reference to our inventory components. Now, I'm not going to be using the enhanced input system for picking up items and such for right now. That's not really what this tutorial series is about, so we'll just get a left mouse button event. And when we press that, we're going to do a line tracer from our camera to wherever we're looking at. So we're going to line trace by channel. Our starting position will be our follow camera, get world location, and then our end position will be that same location with the direction the camera is facing, multiplied by a distance. We'll walk through this real quick. So we can get the forward vector out of this thing, which is just the direction that this thing is facing in world space. And we can multiply that by a distance. So let's convert this pin into a float and say that the max distance that we can pick up items at is like 2,500 units. That might be a little bit too much. If we add that to the world location for our camera and set that to being the end, we now have a line tracer that allows us to potentially pick up an item. So the out hit here, we want to break that hit result, and we want to check the hit actor. On the hit actor, we will try to run the on interacted, and we want to make sure that we choose the message option. We need to pass in the interacting actor so that the items, if we are trying to pick up an item, know what actor they should add themselves to. So we just pass in a reference to self. And then we get a interaction finished. If this function runs, but we don't add anything to the inventory, it will notify us of that with the value of whatever we were returning. This is really all there is to it for adding something to the inventory. That's all we've had to do. So now, what I will do is I will do the debug type, set that to persistent so we can actually see the line tracers for the time being. And if I add this world item, like the rock, for instance, and I play the game, I need to make sure that this rock actually has collision. So for right now, what I'm going to do is not very smart, but what I'm going to do is I'm going to set the customize collision to use complex collision as simple. So that way it will use the complex collision, which is literally just the wireframe of the model, as the collision here. We do need to have some sort of collision on these objects in order to be able to pick them up. But now the line tracer is actually triggering, but I forgot to set up the inventory constructor. So we don't have an inventory to add something to. So that's why it wasn't being added. Now that I have an inventory, I should be able to pick this up and the item disappears. And going into my inventory, I should now see that I have one rock in it, hopefully. And I do. So picking up items now simply works. Now that we have this interaction system set up as well, it is remarkably easy to also make something like a chest. So let's make a blueprint class here. Which will just be a actor, and we'll say BP chest. We will give this chest, first and foremost, a static mesh, just so that we can see it. I'll just give that like a cube or something like that as a shape. That'll work fine. And then we'll also add a inventory component to it, because we're going to fill this chest with an inventory, and then it's going to drop its entire inventory upon being destroyed. So in the class settings, we're going to again implement our trusty old BPI interaction interface, and we will uninteract it. Instead of adding something directly to the inventory of the player, what this is going to do is it's just going to spawn in a few actors. Spawn actor from class, and what we'll be spawning is a world item. And here we get into some interesting stuff. So this world item, we actually want to set the value of the item data asset. And maybe potentially you also want to add something like stack size to world spawn items. That's entirely up to you. But you want to set that on spawning. That's the easiest way to do that. Otherwise you need to then set that afterwards and it can just get messy. So if we go back to BP world item, what we can do is in the item data asset, we can expose this on spawn. And that will, if we now go back to our BP chest, you might need to re-add the node, but it gives the item data asset input. So as the item is spawning in, it's giving the value for that specific variable, and it will be able to use that in the construction scripts as a result of that, which is very, very nice. Now we don't want to just spawn in one thing, we want to spawn in the entire inventory this thing has. So what we'll do is we'll get the inventory component and we'll get the inventory out of it. And the inventory will just do a for each loop. And here once again, we're going to break this and we're going to check whether or not every item has a slot in it at all before we do anything else, just to check whether or not we should even bother. And if there is an item in it, we will then spawn in that item in the world. While we're at this anyway, I'm going to add in a stack size into the world item blueprint as well. So we'll go into the world item blueprint here, and I'm just going to add in stack size as a variable here, because we might as well implement that right now. So what we'll do instead of destroying the actor right away, this is on the uninteracted in the BP world item blueprint, by the way. What we'll do is we'll set the stack size to decrement. And only now if this is less than or equal to 0, will we destroy the actor. So now we have a simple stacking system where we can click on the same item multiple times and its stack will decrease while the stack in my inventory will increase. And this stack size we will also expose on spawn. Because that's the whole reason that we're using this, to be able to have chests drop stacks of items. So we'll get the stack size from our inventory and set that as the stack size for our world item next. And then once all of that is completed, is where we will destroy the chest itself. You can also change this to like a open chest, static mesh, or plain animation or whatever. For now, we're just going to destroy the actor, and the return node should not be after spawning actor. That is a mistake on my part. It should be after the entire loop has been completed. Now, the last thing we need to do is set the spawn transform where these items should spawn in, and the easiest way to do that is just to split the structure pin. The scale should probably remain at 1. The location, we can get actor location. We split the location structure pin as well, and we might as well split the structure pin for the rotation too, because we're going to be doing something with that in a moment. Split structure pin. The Z value we will just put into the Z value, and then the Y value we will add a random float in range to. Something between -200 and +200. Just so that every item spawns in a slightly randomized location around where the chest initially was. And we're going to do the same thing for the X position here as well. Do make sure that you make a new random float and range node and don't reuse the same one, because this will just generate a value once and then use it for both of them. You want these two values to be different. Then for the rotation, you probably want the roll and the pitch to be 0, but you want the random floats again, and we're going to set this to between 0 and 360, so it just randomized how rotated it is around its own axis. And you can make these other two slightly randomized as well. So let's say we set both of those to a randomization of between -20 and 20. Just don't go overboard with these two. And now that we have all that, we can set this chest down somewhere. We can open up its inventory component and construct an inventory, and we can say, hey, I want this to have 5 rocks in it, and then has item to true, might as well. And then I want the other slots to have 10 rocks in it, so we can say 10 rocks has item, sure. And now if I keep forgetting to do this, I probably should set up some automated way to do this on begin play. If I generate myself a inventory, I can still pick up this 1 rock, and we can see that the rock, if I go back into my inventory, is now in the first slot here. Let's actually lock this so that we can keep looking at it as we play. And now if I interact with this quote-unquote chest, it should spawn in 2 rocks. It spawned them in pretty much the same location, so that's a little iffy. But I can pick up these rocks, and you can see it keeps increasing my inventory size, and you can see in my print screens that it is adding them to my inventory. And after the stack ran out, we now have only 1 rock left, and I can 4, 3, 2, 1 pick that up as well, and now I've got 16 stone in total, which makes sense. We had 1 stone just laying there, and then the chest had a stack of 5 and a stack of 10, so in total that is 16. Which means we can pick up items now. We can even have chests that have items, and in much the same way, if an enemy dies, it can just drop its items like that. Which means effectively we now have a functioning inventory system. The only thing that we really require at this point would be adding some UI to it. And adding UI itself is a bit of a bigger task as well. So we'll be starting with that in the next part. Until then though, if you want to check out the project file as it is right now, there will be a link down below in the description to my Patreon and for YouTube members to download the project file and just play around with it and try to figure out how everything works if you're having any trouble or just want to support the channel. It's time to make a UI for our inventory. We have a functioning inventory. I also imported a mesh for the sword, which is part of my low poly weapons asset pack, which you can get on my Patreon or Gumroad, links down below in the description. All this specific model will also just be included with the project files that you can get as a Patreon. I also asked ChatGPT to generate me 2 icons here, 1 for a rock and 1 for a sword. They're not particularly great, but they will do for purposes of today, and that will be making a inventory screen. This is going to be split up into 3 bits. So let's make a folder here for inventory, and we're going to be making a inventory slot. Now we're going to display that inventory slot in a grid, which we can scale up and down depending on how many inventory slots we have, and then we'll make a screen that displays that grid that we can put on either like the player, or when we open up a chest we can display that inventory. So let's get started with the first thing first here. In the user interface we're going to make a widget blueprint, and we'll make this just a user widget, and we'll call this widget blueprint item slots. And this item slot is going to have a couple of things. First things first, we're going to add a size box here. And this size box is kind of nice because we can exactly say how large these inventory slots should be. So in our case, let's set these to 100 by 100. For a good reference, instead of making this a fill screen up here, this is going to change to desired on screen, and that's just going to make our design process a little bit easier here because it actually shows us the size and aspect ratio that we're working with. Now, the most important thing that we need here, eventually, if we want to make this interactable, which is the goal, probably not on this part, but we want to interact through using buttons here, because that's the easiest way to have interaction that supports gamepad control and also mouse and keyboard control very, very easily. In here, we're going to go into the style, and the padding for the normal and press state, we're going to set to 0 in both cases. Because we're going to put things inside this to override all the stylistic looks. This is literally only there, so we have an easy way to interact with our item slots. So let's put a border in here next, so that we have something to work with. And this border is going to have no padding. So in the padding section for the content, we're going to set that to 0. And in the padding for the slots, we're also going to set that to 0. And then for the alignments, we're going to just make this fill the entire thing. Now you can just use a normal border if you just want these square inventory slots. What you can also do if you have a inventory slot image, we can add in an image right here right away. And this will then be our image for the inventory slots. I very quickly asked ChatGPT to generate me something. So I have an image for an inventory slot, which is honestly kind of bad. So let's select that, and now we have that as our inventory slot here. And we can actually make the border itself have a alpha value of 0. And then in the button style, we also should be able to set that alpha to 0. So our button is now just our image. And we'll make a variation on this image which has like a stroke around it or something that we can use when we are selecting the individual slots. But again, that is for a future video. If you want to have an image like this as your inventory slot texture, what you do want to do here is you want to actually wrap that in overlay. Because borders can only have one child object, overlays can have multiple. Because we're going to need to add in yet another one of these borders here. Because we also need to have the actual item image being displayed on this thing, of course. And the way we do that, again, is we're going to make this padding for the content for the time being 0. We're going to set this to align horizontal and vertical so that it fills the entire thing. And then we're going to go back into padding here and we set that to something like 10. So it's a little bit smaller. In this case, I might actually want to set it to like 15, so it really fits within the slot, maybe even 20. Let's go with 20, so it really does fit inside the slot. And once again, in the brush color, we can come down to the A for alpha and set that to 0, so we don't actually see anything. In there, we're going to add in another image, because this image is going to hold our, for now, let's make the default our rock texture here. And now we just got to add our quantity here, because if items can stack, we want to see how many items we have in our stack. So we can add a size box for that, or another border if you want. I like having a size box here. You can put that into the overlay as well. And here we'll be able to say, hey, our size box, I want that to be, in this case, like 10 by 10. Does that sound good? I think 10 by 10 sounds pretty good. And we want to outline that to the bottom and the right. Now, it is exactly in the bottom right now, which is less than ideal. So what we'll do is we'll set the translation to something like -10 and -10. Might be a little bit much. Let's go for -8 instead. So it's nice and in the corner here. From there, we can simply add some text into this size box, and that will first and foremost be way too large, most likely. We want to set the alignment here to being horizontal and vertical, and then the justification to being aligned in the center. And then we just play around with the size. Something like size 6 maybe, sounds good for now. You want to test this out with a sample text. It's best to use the largest number that you expect to display here for testing. So let's, for us, say that's 99. And 99 fits nicely within this box. and 0 also looks nice within this box. Now we can do a whole bunch of other things like outline settings. I can make the outline a size 1 so that we have a little bit of a black outline around our numbers to make them just a little bit more readable. But that's honestly up to what your preference like visually is. For 99, that still looks pretty good. Well, this is the design of our inventory slot. Now we need to make this functional. So everything that needs to potentially change is going to need to be exposed as being a variable. So that will be our text, because of course that's going to be changing when we add new items. And that will be our image, which automatically is set to being a variable. Let's also name these things a little bit better. So this will be the image icon, and this will be our text number. And then in the next part, we're also going to come back for this image over here, which already is by default set to being a variable as well. And this will be image border, because we want to swap the image that displays here when it's selected. Again, not something we're going to do today. This was the most intense part of making the inventory screen. Let's go into the graph up here, and in our event pre-construct, we just want to set a few values here. So in our text number, we want to set something, and in our text icon, we want to set something. And the thing we're going to want to set is going to be whatever is in our inventory slot. And we have made an inventory slot structure before. So let's just make a variable for that. That will be our inv slot, and that will be of type inventory slots. That's our structure that we made. And this one we want to make instance editable, because every single slot is going to have its own values there. And it's also going to be exposed on spawn. So when we spawn in one of these widgets, we can immediately set a value for it if we want to. In pre-construct, we're going to set the text number set text. And the text that we'll be using will be our inventory slot. And let's just break that open. And that will just display our stack size. Let's get rid of these little comments here because it's really annoying to deal with. And we'll hook that up into event pre-construct. Then our image icon, we will set brush from texture. And the texture that we're going to be using will be the icon that is in our item asset. So we can get icon, which is something that we defined before, and we can just set that as the texture that we're going to be using. And now, if we go into our designer again, and we select the root of this, we should see our inventory slot here, and we can say our stack size is something like 50, and we'll see that, I'll zoom in a little bit more, we'll see that update on the screen right here, and we can change whatever item we have. So we want to set this to a rock, now it displays a rock. We want to set this to a sword, it displays our sword, and again, if we want to change this to like 80, it will display 80. So it'll just be as easy as that. If we don't have any items or the stack size is 0, we don't want to display this image and this number. So let's real quick go back into the graph here, and we'll add in a branching node, which you can do by holding down B and clicking, and we can just check has item here, and if it has an item, we do that. And if it doesn't have an item, we're going to take these and do the set visible, or set visibility rather. And we're going to set these to being hidden. And we'll do the same thing for the icon. So we just copy that over and we set the icon to hidden. Now, once this has been set to hidden, we also need to re-enable this to be set to visible when something is added to it. So we also want to add these visibility nodes to the end of our top here. And we're just going to set the new visibility here to visible and hook up our text numbers and our image icon. And now with that, we can set whatever we want in here, but as long as has item is turned off, we don't see anything. The moment we turn on has item, it shows our image and our number and whatever we want. Now, let's make this inventory slot into a inventory real quick, and this will be much faster. So we're going to make a new widget blueprint again, and in that widget blueprint, which will just be a user widget, we'll call this WBP item grid. In here we can either put in like an overlay or a size box, but really all we need here is a border. The border here is going to have a alpha of, let's say, something like 0.6, and we'll set the brush color to a dark gray kind of color, maybe even all the way down to black. Inside that border we'll put in a thing called a scroll box, and this will allow us to put in elements, and if the elements don't all fit on screen, we can scroll through so that we can still access all of those elements, which will be good for inventory, right? Because if it doesn't all fit within the box, if we have like room for 20 slots and our inventory is actually 24 slots, we can just scroll down a little bit and we can still access our entire inventory. Makes it very flexible, especially if you have a game with a upgradable inventory, that kind of stuff. This is really, really nice. And how are we going to be adding those things to here? Well, actually, there's a very easy way to do that, and that is with a wrap box. A wrap box will just add in elements to itself, and whenever they don't fit inside of the parent anymore, it will just wrap around and put them on the next line. It's actually very, very nice. Well, the design for this went a lot quicker, so let's go into the graph here. And what we'll do is we'll put in a variable here, and that will be the inventory component that this inventory grid is going to be displaying. So we'll have a reference to a inventory component that we've made. And we'll also set this to being exposed. And in our inventory component, we have our inventory array, which has all of the item slots in it. And with that, we can just put a for each loop in. So for each inventory slot, we're going to be adding, wouldn't you know it, an inventory slot. So let's do that. Going back into the designer real quick, we do want the wrap box to be a variable so that we can access it from the blueprint graph. So we can now do that with this wrap box, and we can add child to wrap box. And this will take in a widget blueprint and add it as a child there. So for that, we will need to create a widget. And when we create that widget, we're going to be creating a item slot, and that then opens up the inventory slot here as a pin, because we set that to expose on spawn. So we can simply pull through our array element into that inventory slot, and it will populate it right away. And that will then be added to our wrap box. And that is really all there is to the item grid itself. So now lastly, let's make one more user interface, and this will be our player inventory. We can also make a bunch more user blueprints here that can do inventory for different kinds of stuff that we want to display, like an inventory for a shop. We want to make a separate one that will display the inventory of the shop. The inventory for the chest should probably display the player on one side and the chest on the other side. We might get into that in the next couple of videos, but for now, let's just make a player inventory. So this will be widget blueprints, player inventory. And in here, we will finally be using the canvas panel, because we want to actually like scale this with the screen very nicely and stuff like that. And we'll use a item grid, which is what we've just made. We'll put that in here, and we will anchor this to the middle of our screen in this case. I think that makes the most sense. And we'll also then position this at 0, 0. And the alignment for this will be at 0.5, 0.5. And then we can size this however we want. So let's size this up a good bit. Something like this for the normal inventory screen. And don't forget to compile your item grid blueprint, otherwise it won't properly show up in here. But now it will. So whenever we construct this, what we want to do is we also want to have a player inventory variable in here. And that will just reference the inventory component on the player when it gets constructed. So here as well, we do expose and expose on spawn, and we'll just kind of pull that through. So on the event pre-construct, what we'll do is we'll take the item grid and we will set the inventory component that we're referencing here to whatever our player inventory component will be. So that way, whenever we construct the UI that the player is actually going to see, it will just kind of message along whatever information it needs to the actual item grid. Now, there's one last important thing. This just gets constructed once, and then if the inventory changes, it won't display any changes. So there's one more thing that we need to do, and that is make a new custom event in our item grid over here. So let's do that, custom event, and that will just be update item grid. And really all that will do is it will just execute the exact same code that pre-construct does. So if you want to be very good about this, you probably want to disconnect pre-construct, and on pre-construct we just want to update item grid, so it's a little bit easier to read. Now, the one thing that we do want to actually change about this now is, instead of just adding things to the wrapping box, we're going to need to clear it first, because otherwise we have like 16 items in our inventory, and then every time we update, we're going to add 16 to it. So we don't want to do that. So let's copy over the reference to our wrapper box here and just clear children every time we update it. So it will remove everything and then re-add everything with the new information on it. And going over to our third person character here, let's go into the event graph and let's just say the tab key. Let's make that an event. And when we press this, we simply flip-flop between displaying and deleting our inventory screen. Let's create the inventory screen on begin play though, so we always have a reference to it. So on begin play, what we'll do here, we'll add a create widget. The widget we'll create, of course, will be our player inventory, which will take in the player inventory component that we have here. So we can just put that through. And we'll update that to a variable. So promote that to a variable, and we'll call this inventory UI. Then back down here in the tab, we have the flip-flop for doing one thing and then the other, and then the one thing and then the other again. And you know how a flip-flop works, most likely. And all that this is going to do is it's just going to add to viewport whenever we turn it on, and it's going to remove from parent whenever we want to turn it off. And while we're at it as well, the one thing that I have been not doing at all is automatically constructing the inventory whenever the game starts. So let's do that as well. Let's do that before we create a widget, actually. That's quite important. And let's just construct the inventory with inventory constructor. And then in our player inventory screen here, we will, in the event construct itself, use our item grid, and we'll just run the update item grid when it gets constructed. So first time when it shows up, it will actually already have items populated in it. And as you can see, now that we open up our inventory, we can see our items in there. There's still going to be a little bit of an issue, because when I pick up these items over here, also I enabled physics on the items because it looks a little bit better. It's not exactly picking them up. So this is where we go back into our third person blueprint, and we have our simple interaction system here. And here we check on interacted. If the interaction is finished, it could very well be that we don't have an interaction with an item here. And that might be worth checking whether or not we interact with an item or not. At the moment, we're not going to do that. I'm just going to say, if our interaction is finished, for now, we just assume that that's adding an item to our inventory. What we'll do is we'll get our inventory UI. We'll get the item grid out of that, and we will update that item grid. And that we'll put into the true of this branch node. And now it should update our inventory, which we can open up. And now we add in our sword, and we can pick up some rocks, and we can see our inventory displays everything that we have. We can close it again, and we can open it again, and it still has everything in it, because it's just displaying data that we already had built previously. So that's the basics of displaying a inventory system. Of course, this at the moment still not interactable. We can't move items into different slots. We can't like split stacks, anything like that. That will be a little bit more advanced. We'll get into that eventually. But for now, this is how we set up the display of our inventory. So we don't need to actually go through and look at our variables to check whether or not our inventory system works. Making it interactable is the next step, because once we do that, we can start making chests and shops and everything you want to do with inventories and items. We have a inventory that can display things, but it is not yet interactable, and that's kind of necessary for a useful inventory. So let's today look at simple drag and drop operations to move items around and swap item slots. And then in the next video, we'll look more into the advanced stuff like merging and splitting item stacks like you would do in a game like Minecraft. For now, let's get into this. So we've got our inventory split up into a slot, a grid, and then an actual display. We're going to be doing all of our coding here in the inventory slot. Let's go into the graph here, and we're going to go into the functions, and we'll override a few of these functions. The first that we're going to override is on preview mouse button down. This is an alternative way to detect mouse button down that doesn't have like a callback. And that's useful for what we're going to be doing here with it today, because we're going to be using that for a drag and drop operation. For now, this is going to be relatively easy, but we're going to build this out a little bit in the next part as well. And here we simply want to check if the mouse event is mouse button down. And then we're going to check the mouse button. You can just click on this little keyboard value and then click on the left mouse button, and it will automatically populate this with the left mouse button. Now, this is a little bit annoying because this does make it specifically a mouse and keyboard related thing, so any controller might have some more trouble with this. We're just going to be doing this setup easily with just the left mouse button for the time being, because otherwise all of this is going to end up being very, very chaotic. So when we have seen that this is indeed the left mouse button, or whatever key we are mapping to this, if you're using the enhanced subsystem, at that point, we're going to say, hey, we want to start a drag operation. And the key that we're going to be dragging will be, in this case, the left mouse button. And that will also give us a event structure here that we can use as the return value. Running this node is going to start off a second separate function on here. And that is going to be the on drag detected. So this will start a drag and drop operation, which we'll get into in a minute how that works. And when a drag and drop operation starts, this event will fire. And that will have the pointer event, which is whatever we put into here. And we also actually need to connect a mouse event up to the pointer event, and that's just going to pass it through to the drag and drop operation. Now, in here, we want to check, just for future reference reasons, whether or not we are pressing the left mouse button, or dragging the left mouse button rather, because in future we're also going to be checking whether or not it is the right mouse button, because we're going to be splitting stacks with the right. So we might as well implement that now. And we're going to be cutting in here real quick. I mixed two things up, and what you want to do, first things first here, on drag selected, you can ignore everything to the right side, we'll do that in a moment. You want to check again, is mouse button down? And we're going to go for the left mouse button in this case. Doing that into a branching node. Now, let's go back to building out the rest of the system that you see on the right hand side here. Now, we're going to pause this here for the time being, because what we're going to do when we are dragging something, we want to have a little preview window of the item that we're dragging around. So we need to make that little preview window. And it's actually quite easy, because we're just going to copy over the item slot, just duplicate it with Ctrl and D. And we'll call this WBP item drag preview. And this will very easily just be kind of more or less the exact same thing. Don't mind my scroll wheel being a little weird. Except we're going to remove the border, because we don't want to be dragging around the border. That would look weird. And in the icon, we're going to come up here to the tint. And I want to set the tint for this to be a alpha of about 0.5. So it's a little bit see-through. That way it's clear that it is a preview image. Still want to display the number and everything together with that. So in the graph, all of this we actually want to keep. But we can get rid of all the override functions that we literally just made, because we're not going to be needing those. And that is how we make the drag preview. It's just that easy. And the reason that we need to make that is because we're going to be needing to add that here. So we can create a widget, again, back in our item slots in our on drag detected function. And there we can make our drag preview. We want to give that the inventory slot that we are working with right here. And since we're just going to be dragging around the entire inventory slot for now, we can take the inventory slot structure that we have on the item slot itself and just put that in there. And that's going to just make a kind of a ghost copy of the inventory slot that we're dragging from. Now we need to create a drag and drop operation. And for that, we need to make a class, but I'll add the node first. So we can create a drag and drop operation. In this, we're going to need to put in a drag and drop class. It has a default one, but that's not really going to do for what we need it for in the future. So we might as well jump in right away and create that. I'm going to create it in the inventory screen here because it's UI related. Coming up to blueprint class, we can just type in drag, and that will allow us to make a drag drop operation. So let's call this DDO for drag drop operation, drag in slots, something simple like that. And here we can put in some information on stuff we want to pass through. So what we want to pass through is a couple of important things. Is we want to start working with indexes now. Specifically, if we're going to be moving things from one inventory to another in the future, if we're going to be worrying about splitting and merging stacks, we want to have a reference to what the original index was where we got things from in case we need to return items to that slot. And in the same way, we also need to have a reference to the original inventory component that this thing came from, because it is very possible that we're going to be moving things from one inventory component into another. And again, if something fails, we want to be able to return the items where they came from. So let's make that inventory component. Let's actually call it source inventory component to make sure we know what we're talking about. So source invcomp, and we'll make that a inventory component reference. And then we'll also say our source index will just literally be a integer. And both of these are going to be instance editable, and they're going to also be exposed on spawn, which is quite relevant because we're going to be setting them right away as these things spawn in. And while we're at it, actually, what I'm going to do is I also want to change things around a little bit so that the inventory slots themselves have a concept of a index, and you'll see why in a second. Because we have our drag and drop operation now, we can set it to our custom one, and that will allow us to put in an inventory component and a source index. Now, we need a value for both of those. And the source index, the easiest way to facilitate that is to just give our inventory slots an index. So let's go find where we created that blueprint structure for that. That is right over here. And let's just add the variable for the index on it. You could also put this on the widget blueprint if you preferred. I like doing this because it's easier to move information around with this. And you will see why in a second. Because now we have this inventory slot and we can just simply say break that open and we have the index. And we can immediately put that in there. That said, we are not setting the index value anywhere. And in order to set this index, we're going to need to come back into our inventory component here, because we have that function inventory constructor, if you remember, which just adds our inventory slots. But now what we actually want to do is we want to give all of them a value for their index, at least. So what we're going to do is we will, when we add the slots to the inventory, we'll still have them at has item none and stack size 0 and item asset being nothing. But we're going to hook up the index from our for loop into the index here. So every single one of the slots on our array will have a number that references their index. Even when we're taking something out of the array and then doing something with it, we will still have that information on where in the array it might have to return to at some point in the future, which is just good information to have. So that sets up our source index. We needed a little couple changes there to make things work. But now for the source inventory components. There's again a couple of ways we can do this. I just want to add a inventory component reference to every item slot. So let's make this the inventory components, and we'll make that, of course, of type inventory component object reference. And we're going to set this to instance editable, obviously, and expose on spawn as well. Then coming over into our item grid, where the item slots get spawned in, we can refresh this node here, and that will now have inventory components as a new pin. Our item grid itself already had a reference to the inventory component, so we can very simply just pull that through, and now whatever this is getting set to, all of these slots also now have a direct reference to that same inventory component, which is very, very nice. And with that, we can simply hook that up into here, and now our drag and drop operation will be able to access that information as well. And from there, we can simply hook this up into the return node. The drag and drop operation that we've just made will be our return value. And the widget that we have just created for the drag and drop preview is going to go into the default drag visual. So what this will do is it'll make the temporary inventory preview visual, and it's just going to put that at the location of your mouse cursor. You can even create a bit of offset to it if you want to, or set the pivot to somewhere else. For the time being, we're not going to bother with that. And now you'll be able to see, we still can't actually do anything with it, because when we open up this widget, we don't actually have our cursor and we can't interact with it. So in order for that to be fixed, let's go into our third-person blueprint here. And we're going to be changing a couple of things around with the way our item update here works as well, but not for right now. What we're going to be doing for right now is when we open up the inventory here, we want to show the mouse cursor and make our widget interactable. And for that, we're going to need to get the player controller. And when we have the player controller, we can set show mouse cursor, which is just a bool that shows mouse cursor or not. So when we do show the widget, we want to, of course, show our mouse cursor. And then when we disable the widget again, we want to not be showing our mouse cursor. And do make sure that you are hooking up the player controller to it. One more step is needed, because we also need to set our input mode. We're going to set input mode to game and UI in this case. You could also do UI only, but that would not work too well with the way I make the UI visible and invisible right now. This event will no longer run if the input mode is set to UI only, because this is a game input, not a UI input. So if you do that, you need to make something on your UI to close out of your inventory again, rather than allowing it to be key based. So for now, we're just going to do it this way, because that's the easiest way. We want to set the widget in focus to be our inventory UI widget. And we don't want to hide our cursor during capturing. When we remove the widget again, what we want to do is we want to set input mode to game only. It is not really an issue, usually, if it also still is able to interact with UI, but if you've got other UI elements, that might mess you up in some way, so just set it back to game only to be sure. And now you'll be able to see if we pick up this sword and we drag and drop this around, we can see we have this preview. Of course, it doesn't really do anything yet, because obviously for that we need to program in functionality, but we've got a good start going. Luckily from here it's actually relatively simple. So let's open up our inventory component again, and we're going to make a new function in that, and we're just going to swap slots. This function will take in two parameters, which will both be simple indexes. So we'll say index source and the index destination. And both of those will, of course, be integers because they're going to be indexes. And I mistyped. I typed spawn slots. It will be swap slots. We'll come back later to this and allow this to then also swap slots between different inventories, like if you have a chest and you want to swap things around. For now, this is only going to work within the one inventory, just to keep things a little bit simpler. And what we're going to do here is we'll get our inventory array, and there we will just get a copy of both of those indexes. So we'll just get copy from both the index source and the index destination, and then we're going to save those inventory slots with all of their data temporarily. And the way we do that is we right click this and we can promote to a local variable. The difference between a local variable and a normal variable, we'll call this, let's see, source stack, and we'll do the same for this one, which will be our target stack. The difference between a normal variable and a local variable, if you are wondering, because I don't think I've covered that yet in many of my videos, is these exist as long as the object exists, in this case the inventory component. So this is just going to always exist, and once we set a value on this, it's going to keep that value, and we can always refer to that. Local variables only exist within the context of a specific function. So if I go into my inventory constructor function and you keep your eye on the local variables here, they will disappear because those variables only exist to this function. And when this function is done with running, it's going to discard the values and the memory allocated to keep those values around. So for optimization, it's good to, when you can put something as a local variable, to do that, because you're going to be saving a bit of memory, but it's also quite useful because if you ever refer back to this and you run the function again, it's going to start the function with those variables being empty. And that's exactly what we want here, because we're just using them to store the information of those two slots. We'll get our inventory array again, and we'll set the array elements, and we're just going to swap these around. So the reason that we're saving these, by the way, is if we set one of the inventory slots to be the contents of the other inventory slot, then we don't have the information on the other inventory slots anymore. This way they get saved to something separately, and then we can safely swap things around. So we want to set the index source to whatever the target stack was, and then we want to set the target index or the destination index or whatever to whatever the source stack was to begin with. Now, for swapping these items, there's also a bit of an issue with the swapping around of the indexes, and we can be very bothersome and fix that up in here. But what we can also do is in the item grid, every time we make this new item slot, instead of just passing through the array element as a whole, what we can do is we can split this structure pin, and we can break the inventory structure and just pass through everything except the index, and the index will just be the thing that we take from the for each loop. This way, everything still gets an index on setup with the for loop that we did earlier in the video. But whenever we change something about the inventory, the index for the inventory slot structure also properly gets updated to whatever new slot everything is in. And now that we've updated that, we're going to need to update the visuals for the UI again. In order to do that, we could make a inventory UI reference in here and populate that and then just run that function directly every single time. What we're going to do instead is we're going to make a event dispatcher, and we'll call this on inventory changed. And this is simply going to call out whenever we run something that is going to change the inventory. So just to be thorough, we're also going to go back into our add item here. And at the end of our paths here, so before the return nodes, we're going to put in the inventory change as well. Because as you remember at the end of the last video, what I said about the way we're updating the inventory visuals right now is we're just doing it on interaction. But what if we are dragging things from one inventory into another? That doesn't involve our interaction system. And what if we're interacting with something that's not inventory? Then we don't need to update the inventory. So this way we will just link the update inventory to whenever inventory gets changed. And while we're at it, again, might as well also do this for the remove item. So we drag this in, we call, and whenever an item gets removed, we also want to update our inventory visuals. And the way we do that is coming into our item grid. We have a reference to our inventory component. On construct, what we're going to do is we're going to bind event to on inventory changed. So that's this one here. That's going to make us this node with a little red pin in here, and this will be able to be connected to custom events. So we can hook it up to that if we want to. What I prefer doing is just simply making a custom event that runs that other event. That way, if we want to add other things to on inventory changed, which maybe themselves don't have anything to do with updating the item grid for whatever reason, it's just a little bit cleaner. So update inventory delegates or event dispatcher. They're called delegates in C++. And that will then just run the update item grid. we're running into a bit of an issue here that you might have also run into if you're playing ahead a little bit, and that is that this inventory component doesn't have a value yet on event construct for this widget. It only gets set moments after it is constructed, but by that time this is already run and failed and we're not binding anything at all, which is a little bit annoying. There's a lot of reworking that we can do to make this work a little bit better. Honestly, it's a little bothersome to deal with in general, so I'm going to show you a little bit of a hacky way to get around this, and that is because we're fairly confident that it's only going to take like one tick, one frame of processing before this thing has a value and will just straight up work. So if we simply put in a delay node here, and we can set that to like a very low number, like 0.1 seconds. You can even go lower if you want to, like you can set this to 100th of a second, which will just wait one tick. I like to play a little bit more safe though, and go for 0.1 seconds. That will event construct, then wait for about 1/10 of a second, at which point this value is now populated and this will work. Even on very slow systems, it's a very simple thing that we're loading in. It's not going to take more than 1/10 of a second. This will be fine. It's a little bit of a hacky way to do things, but it works, and that is the most important part. So now that we have all that in place, let's go over that real quick again, because we just did a lot. We updated our on-inventory change. And with that, we can come up here to our interaction system and remove the update item grid from that in our third person character, because we no longer need that. Now, we did a lot of things very quickly there, so let's real quick go back over them just as a recap. Our inventory component now has a couple of changes with this event dispatcher that we added to everything that is changing the inventory directly. We also added this swap slots thing that gets the two slots that are being swapped around. It's going to save them to a safe and separate location, and then it's going to set those two slots to the value of the other slot. And then of course call the on inventory change, which whenever that is called in the item grid, it will run the update item grid function that we've made before, so it reflects our changes. So now let's check whether or not that works. Let's pick up this sword, open up our inventory, do our drag and drop. Now this starts our drag and drop very, very well. The only issue is that we now need to add in the dropping part of the drag and drop, and that itself on the item slot again is an overrideable function, so we can just on drop. This has the operation, which is the output from our return node here. And it also has the pointer event, which at this point we are used to. For the operation, we need to cast this to our drag drop operation drag inventory slot, because this is a generic drag and drop operation. And we'll check our inventory components, and we will want to swap slots for two things, and that's our source and our destination. And we can get our source index because we passed that through into our drag and drop operation before. And our destination index is just going to be the index of our current inventory slot. So we get our inventory slot structure, we break that, we get the index out of it, and that's now simply going to swap any two slots that we are dragging and dropping between. So this part of it is really quite easy. And now you'll see, if I pick up the sword, and I pick up a couple of rocks which are bouncing all over the place, you'll be able to see that I can swap these into different places very easily. And if I drag it onto a existing item slot, it swaps those two around. And realistically, even when I'm doing this, it's still swapping the slots around, but when I'm swapping something with an empty slot, it just looks like I move from one slot into the other. So now we have the capability to organize our inventory a little bit better. Next time we'll be taking the next step into also allowing us to split our stacks. So if we have, for instance, 8 items here and we want to take half of them and put them into a different slot, we'll be able to. Things get a lot more complicated very quickly with that, but I do think that is important to have as an option in your inventory system. So we have an inventory in which we can drag around our items, and that is all well and good. And for the most part, that'll probably cover whatever you need to do. But I want to take this a step further, and I want to go like full Minecraft system where we have the ability to split our stacks. Meaning that if we have these 11 rocks here, I want to be able to right click and drag rather than left click and drag, which I can already do, and split this stack up into 2 separate stacks. This is where things become a little bit more complicated because we're going to have to think about a lot of edge cases, and that's always a nightmare. So let's dive right into it. We're going to be doing most of this in the item slot again. If you haven't seen the last part of the series, I do highly recommend just going back to the start of the series to begin with. But especially for this one, you do want to have the context of the last part where we set up all the drag and drop stuff. We're also going to pull up our inventory components because we're going to make a couple of functions on that. We've got a swap slots function already, which works perfectly fine. But now what we need is something to split a stack. So something that will take in a stack, split it in half, remove the half that we split away, and output the new stack which has that half. If that makes any sense. If it doesn't, hopefully it will as we go along. So let's make a split stack. And for this, we are simply going to require an input for the slot index that we're going to be splitting. And that will be our integer. We'll simply use our inventory here and get a reference. Let's do a reference because we're going to be directly influencing it anyway to whatever slot that we're working with. And what we're going to be doing here is we want to break open that inventory slot to get all the information out of it. And we'll get the stack size and first and foremost check whether or not it is greater than 1. Because if it is not greater than 1, there's nothing to be split here and we're just going to do nothing. So if that is the case, we simply return and our outputs will include the split stack, which will be a inventory slot. And just for readability, really this isn't really going to do anything, but for readability I like to just like make one that I can see is entirely empty. We do want to pull through the slot index in this case though, so we actually do need to make one. Now, if it is greater than 1, what we want to do is we want to get our stack size and divide it by 2. This will be a rounded division because we're working entirely with integers, and that is, for our case, really fine. But you should be aware that that means that if we have 11 items, one of our stacks, either the split stack or the original item slot, is going to have 6 items and the other one 5. So we do want to keep track of that in some way, shape or form. And the way we're going to do that is the result out of this division we will subtract from the original stack and then also use as the return value so that it always matches up. And the way we're going to do that is by set var by ref, of course, if that branch is true. And the value here, we're also going to simply make a value. And this will be quite simple because it will be the same values that we have. So has item is going to be has item, stack size we'll get to in a moment. The item asset itself is going to be the same and the index is going to be the same. But the stack size, we're going to take our stack size and subtract from that our stack size divided by 2. And this gets very messy very quickly. So do be aware of where all of these lines lead. After that, we will add another return node, which requires us to make another return split stack. So let's just copy over the make inventory slot. That will be our return. And our return will be exactly the same again as our original. So has item being the same. The stack size will be our output from our stack size divided by 2. The item asset will be the same and the item index. And actually, I made a little bit of a mistake. What we want to do is we want to promote the output from this to a local variable. Let's call that to subtract, which of course will only do if the output from this branch node is true. And we'll subtract that from here. Because of what was happening, I'll just tell you right now, I didn't think about that while recording this, is we're setting, of course, the structure here to its new value. So by the time we get to this return node, it's just looking back through this string over here to this data asset to the already newly updated value, and it's then dividing that by 2 as well. So by instead of doing that, saving this as a separate integer variable, we can just put that into the stack size for our return value here, and that will work a lot better. And for the source index here in the split stack function, we might as well pull through the original one as well, so we have an easy reference to that. And this will allow us to calculate a stack split, which is the first and most important thing that we're going to be doing. So now that we have this, let's go back into our item slot, and on our preview mouse button down, here we want to check if it's not our left mouse button, we want to check if it is our right mouse button. So again, you can just click on this little icon and press your right mouse button, and it will just fill that in for you, which is very, very nice. And we connect everything up as you expect, and then we detect a drag, and this time we're going to be dragging the right mouse button, works the exact same again, and the return value will now be the output from this node instead. So this way, if we go into our on drag detected function, we can now check for is mouse button left down again, which does what we programmed previously, but that also passes through the value of our mouse button. But we can also check whether or not it was the right mouse button that is being dragged, because this pointer event just passes through the value of whatever key, or in this case mouse button, is being used. So we can make a new branch for that. And really this will kind of be doing the same thing. So sweet, it's not that complicated. We just create a new operation here, and it's only for the dragging and dropping bits that we need to add in some changes. Because instead of just copying over the inventory slot, that's obviously not what we want to do. What we want to do is we want to get our inventory component, and we want to split the stack in this inventory. So we use our inventory slot here, and we're going to break that up so that we can get the index out of it. It will now split up our item stack, meaning that it will remove the proper amount of items from the stack that we're right clicking on, and then it will return to us the split stack that we have taken away from it. So that is going to be the thing that we put into the input here. And just to test this out, what we're going to do after everything is connected up, that should be in the true, not in the false, that's my bad. And much the same, this should also be connected up. Again, you just want to copy what happens up here, down here, but with different mouse buttons. It's quite simple. And with all that, we should be able to pick up a couple of rocks here, open up our inventory, and see we have 10. And if I right-click drag, you should see now that is 5. And this will still work as the normal moving, because we haven't implemented any code other than that for it yet. Now, I do think in this split stack, what we maybe want to do, and this is entirely up to you, but as you could see a moment ago, the inventory stack itself doesn't update. It doesn't become less until we actually put down our items in another slot, which I don't like. So what I'm going to do is at the end here, I'm also going to call on inventory change. And with that, we should now see that it immediately updates. So I'm dragging around 2, and this one now only has 3. Still though, we don't have the ability to place our split stack into a new slot. So let's get into working on that. And for that, we're going to go back into our item slot here, and we're going to now go into on dropped. And here we're going to add some new stuff. I'm going to first and foremost get rid of this print string, which I added in the last episode for some troubleshooting. And now we want to see whether or not we are left click dragging and dropping or right click dragging and dropping, because that does make a certain amount of difference. And this is also where we're going to have to code in quite a lot of our edge cases. So we're going to spend quite a lot of time in this function here today. First and foremost, we want to get our pointer event and we want to get the affecting button. And we want to check whether the affecting button here is equal to our left click. Because if it is, we're just going to do what we have programmed in before, and that's just swapping the slots around. But if it is a right click, we want to do something else, obviously. And we'll get into what that is in a minute, because we want to, again, get affecting button and check if it is equal to a right click instead. For the most part, we can assume if it's not a left click, it will be a right click, but there's no real harm in double checking. If there's somehow like a middle click thing going on, which you don't want to have any behavior, it won't do anything with this setup now. And here we want to check first and foremost whether or not we are going to put this into a slot that has no items in it at all. Because in a moment we're also going to want to check whether or not we want to maybe merge with an existing stack, which may or may not be the next video depending on how long this takes. So we check our inventory slot that we're dragging onto, which is this one, and we'll break this open or just split the structure pin, that works as well. And we also want to check if has item already. First we're going to implement the code for there not being an item in this slot yet, because that's the easiest thing to work with. Going back into our inventory component, let's make a function for that, and that is put in new stack. We'll just simply call it like that. And the input for that is going to be the inventory slot index. We just want to check that one index, which will of course be an integer, and we'll simply say, hey, get our inventory array, and we'll set the array element to whatever item we'll also input into that index, and that's kind of all there is to it for this. I'm not going to lie to you, it is a very simple function. Of course, we do want to also call on inventory change here. In our inventory item slot, we'll get our inventory components, and if there is no item yet, we will set new, put in new stack is what we call it. We'll use the inventory slot index that we have here, and now we need a way to get the item stack into that new slot. So let's take a look at the best way to do that. The easiest way to do that is just to go into our drag and drop operation here, and also add that as a potential thing that we might be sending through with it. So we'll call that the inventory stack, and that will be of type inventory slot. We want to make it instance editable and expose on spawn. Now, if we refresh these nodes real quick, we'll see that we now have the inventory stack in there as a option for these two nodes. For the top one, we're here not going to really use that because we're using the index-based system, which is a lot more robust. But for the bottom one, which is the split stack, it is very nice to be able to use the split stack output from the function that we made as a input into our drag and drop operation. Because then if we go back into our on drop, what we can do is we can get from that cast to drag inventory slot, we can get the inventory stack as just a whole thing, and we can just use that to put our item in a new stack, and only if there is not already an item in there. So now I can once again pick up some rocks. I probably should make this easier for testing purposes. I've got 10 rocks, and I can drag and drop 5 of them into this new slot, and I can drag and drop 2 of them into this new slot, and so on and so forth. Now, there is one last issue that I want to cover, and that is if we're trying to drag this onto an item slot that already has an item. There's already one item taken out of this stack, but this is going to fail, and that item is just going to disappear. So, in case of our operation being something that we're not allowed to do, we should go back to our initial item slot and add back in the amount of items that we've taken away. So here, if the slot already has an item, what we want to do is we want to run a different function. And we're going to make that function on the inventory component again. And that is something like add item to stack. We already have an add item function, but that just adds an item to the first stack that it finds the right criteria for. This is going to be a function that adds a specific amount of items to a specific stack. So this will take in the input for the index, so that is the stack index that we'll be adding to, and this will also take in an integer for the amount to add. This can be relatively simple. What we'll do is we will get a copy or a reference, it doesn't really matter in the end, and we'll check that index, we'll split that structure pin, and then we'll also set array element on that same index. And what we'll just do is we will split this structure pin too, and we'll just pull through the has item, we'll pull through the item asset, we'll pull through the index. The only thing that we're going to do is the stack size is going to be our stack size plus the amount to add. And that will then go into our item stack size. Now, there's one quite important thing here, and that is we still don't have a method here to make sure that we are not overflowing a stack. Since we're going to be mostly using this for the time being as a fallback for when we try to add something to a stack and it isn't allowed to for whatever reason, we already took it away from that stack to begin with, so adding it back in isn't going to be an issue. If you are going to use this for also merging stacks, which we'll be doing in the next episode, that's going to be a little bit more troublesome. And as always, we want to call our onInventory change so we can update the visuals. Anyway, we can now simply add to item stack, and the stack index and amount to add we can just take simply from the inventory stack that we have here. So let's break that. The stack size will be our amount to add, and our index will be our index. And when we compile that, we should now be able to see if we pick up a couple of rocks before they tumble all over the place and are gone. This should be good enough. We can split our stack here, and if I try to split the stack again, I'm just taking away 1 and trying to put it onto a item slot that already is populated. That 1 will then go back to its original slot, and this will again go up to 3, as you can see. Let's test that out with a slightly bigger stack. So we've got a stack of 8 and 7 and a stack of 4. This is now splitting up into a ghost stack of 3, and the original is 4. Let's try to put it in here, and this goes back to 7 now. And this goes back to 4 now, and as you can see, everything works just as you would expect it to. So now we've got drag and drop operations which don't randomly delete items, and we can still split things up very easily. And of course, we still got our left click operation that can just move items around. Now, things can't merge together yet. We're going to be looking at that in the next video. Really, merging things together just ends up being a combination of all the things that we've already set up with a little bit of extra logic just sprinkled in to make everything work. But we're really getting there. We almost have a fully functioning adventure game inventory, and after that we can get started on things like chests and shops. Fantastic. We have an inventory, we can swap around slots, we can move around slots, we can split up stacks as much as we like, but the one thing that we cannot do yet is merge those stacks back together, and that is quite an important bit to get right here. So let's get into that today, because there's quite a bit to this. We have a lot of edge cases. We have merging things together with a left click, we have merging things together with a split right click. We have to build in things to prevent it from going over the max stack size, and there's just a lot to worry about here and a lot of edge cases to program in. So let's get started with that. We're going to open up our inventory components because we need to do some stuff in that. And then we're also going to open up our item slots. Now, first things first, we're going to add a new function to our inventory component that is going to allow the merging of 2 item slots. So let's make a function for that and call it merge stacks. And that's going to have a couple of inputs. Of course, it's going to have the 2 slots that we're going to be merging. So that will be the source slot and the target slot, both of which will obviously be a inventory slot structure. So inventory slot structure, there we go. But then, since we're also going to have to deal with left click and right click separately, we can make this into 2 different functions if we really wanted to. I personally prefer it to all be inside this one function so that we can just throw it into other UI elements and it will just work. So For that, we're also going to add a third parameter, and that will be our pointer event. And that will be of type, you would be surprised to learn, pointer event. And this is just going to carry whether or not we're using the left mouse or the right mouse operation. But we'll only do that at the very end. We'll just make the left mouse version first, because aside from that, it's just a lot of copying work to begin with. So we'll add in a branching node here, and we'll get from that the affecting button, and we'll just check whether or not that is equal to the left mouse button, and we'll get back to this branch at some point in the near future. The next thing we're going to do is add another branch a little whiles away, just to make sure that we have enough room. And this is going to decide whether or not we want to just merge two stacks together, or whether or not we do a little bit extra trickery in math, because two stacks don't fit on each other. So let's take a look at that. We can get our source slot and break that apart. And then we also get our target slot and also break that apart to get all of the internal information for both of them. If we want to get our source slot, stack size, and we add that to the stack size of our destination slot, so the amount of items that are already in there, the output from this is not allowed to be larger than the max stack size of any given item. We have an item asset, we can take it from either one of these because they're always going to be the same item. We're checking that beforehand anyway. So I'm going to take the top one in this case, and we'll get the maximum stack size. And here we can simply check whether or not that addition operation results in something that is less than or equal to that stack size. Let's move that over here to where it belongs. If these two things added together are less than or equal to the max stack size, we can simply just add them together, and that's the simple bit. Because we can just take our inventory array here, and we can say set element, break open this structure pin, just so that we have all of the pins separate from each other. Connect it up to the true, and then we just want to set the array element for the target slot, the thing that we're going to be putting things into. The index taken from that, and we can just add a rerouting node here, because that's also going to go into the item index. Then the stack size is simply going to be the output from this little thing over here, because it's going to be our source plus our destination is going to be set to our destination. The item type we can simply copy over from one of the inputs. Doesn't really matter which one you pick for this one. And the same with our has item. This also can just be set to true, to be fair, because it's always going to be true when we're merging things together. But I just like to connect up variables just to make sure, and it feels nice, right? It just feels nice. Then though, we have added something to our target slot, but we haven't removed anything yet from the source slot that we've been taken from. So what we'll do is we'll copy over the set array element. Of course, we'll be working with the same array here. But now instead of taking the indexes from the target slot, we'll be taking the indexes from the source slot instead. So we want to set up the index here and the item index from the source slot. And then we want to just make this one entirely empty. So has item is going to be false, item stack is 0, and the item asset will be set to just a null pointer, like this. That way it actually removes those items from the slot that we've taken them from. And once we have done that, we can simply call on inventory changed, so that the inventory visually updates as well. Now, the next part is the left click version, which is still what we're working with here, of what if this is false? What if I'm trying to add something to a stack that doesn't allow for that much more room? So, for instance, our stack size for the rocks at the moment is 64. What if I already have 50 items in that stack and I'm trying to add another 20? That would add 70, and that goes over the maximum stack size. So we need to implement something for that as well. Now, we're going to be using another one of these set array elements, of course. I'm just going to copy over the node that references the inventory. And naturally, just as we were before, we're going to use the target slot for the index, because we're setting the target first. The item slot can just be copied over from either one of these nodes. Again, it doesn't matter. The has item slot, again, same, or you can just set it to being true, whatever works for you. But the item stack size is actually remarkably easier, because the entire point of the setup that we're making here is what we're trying to add is going to overload the stack size. So the stack size is always going to be maximum, and we already have a reference to whatever the maximum stack size is allowed to be for this specific item. So we can just put that into the set array element and we'll be fine. This is the easy bit, but now we need to calculate how much over that stack size limit we go and put those items back in the stack that they originally came from. Because if you're trying to add 20 to a stack that already has 50 and it's getting set to 64, there's 6 items remaining left over. That what are we going to do with those 6 items? And those 6 items need to go back from the stack that they were originally taken from. So the way we're going to do that is using the add item to stack function that we made in a previous video. The stack index that we're going to be adding them to is going to be our source slot. So the top one in this case here, the thing that we've been taken from, that's what we're going to add them back into. So that will be the index that we're adding to. The amount to add is a little bit more tricky to calculate. Not that much though, don't worry. Because what do we have? We have the maximum stack size and we have the amount that our 2 slots will be added together. If we take the outcome from this addition operation and from that we subtract the maximum stack size, we now have information about how much overboard we're going. So again, if this ends up being 70 and our maximum stack size is 64, the outcome from this little subtraction here will be 6. And we can just set that to being a local variable, so we have a place to save it. We'll just call that remainder. And that way we have a variable that we can access whatever the remainder should be, even if we set this array element, because at that point all the calculations using these inputs are going to change as well. So it's a good thing to put this into a separate variable that we can access even after we change the array element, because we need to use it here. And the amount to add will be our remainder, because we're adding back that remainder to the original slot that it came from. But now we have a similar issue as to what we had here. And that is that we are now adding the remainder back into the original slot without taking anything out of the original slot. And that's kind of due to how we have the left click functionality set up. We're not removing anything with our left click and drag the moment we start our left click and drag operation, like we are with the right click and drag operation, because we also need to have some functionality for swapping these slots. So it doesn't really work that well with it, and that's why we're making 2 different implementations for either left click or right click. Right click we'll get to in a minute. But this means that we still have to subtract the amount that we have added to our new slot from our original slot. And of course, that's actually quite easy, because what we can do is we can just take this stack size over here and we can multiply that by -1 to make it negative, because it needs to be negative. And then if we just add the remainder to that, this will now be the proper new amount. So we are subtracting the amount from the original stack that we're trying to move, but then we're adding back in the remainder for the amount of items that didn't fit in that slot. Doing that together and using our add item to stack function like that will mean that we now can left click merge things together. And of course that also needs to hook up to call on inventory changed. Now this is the left click version of the entire thing, and it looks like a mess, but that's just because we're going through this tutorial and just willy-nilly hooking things up. If you're looking into the actual project files that I'm going to be including, maybe not the episode by episode project files, but definitely the finished project files for the entire series, everything will be ordered a little bit more neatly and more readable. And if you want to check out those project files, you can do so in the links down below in the description to the Patreon or for YouTube members. All that self-programming out of the way, let's add in the right-click version. So we can also go off of the false pin here, and that we'll just assume is right-click. And what we'll do there is we'll just copy pretty much all that we have here, and we'll paste it down here, which is less than ideal, but that's just the easiest way to get all the information that we need to have. So we need to reconnect up a couple of things, that being the max stack size for the items can be taken from either one. And we need to take the stack size from both of these and connect that up to this math node that we have down here. Both of these indexes should be the destination slot, so that's the bottom one down here, or the target slot as I called it. So hook that up into that index, and this one as well. And then both of these need a reference to the inventory array too. So just need to hook up a couple of things that I didn't properly select is really what it comes down to. The item asset and the has item for this one, also copy those over from the destination or the source. In this case, it doesn't really matter. And then this one also is an index that needs to go into the destination slot index. Don't forget to hook up the item has item to something when you're copying this over, because I did. And that made me really confused. And also the item asset itself. Don't forget to hook that up. Somehow I entirely blanked on that. And that's really why you don't want to have a blueprint like this, because it's very easy to miss out on things. And I believe with that we're pretty much there, because the only real difference between the top one here and the bottom one here is that in the bottom one, if we're doing any right-click operations, we don't need to subtract from the original slot, because that's just baked into the way our right-click operation works to begin with. Now, you could make an argument for maybe you shouldn't have done that, and you should just make it streamlined between left-click and right-click. Personally, don't think this is that big a deal, and I really do like the fact that when you right-click and drag to split a stack, it immediately shows you the new number on the old stack. So that's kind of the reason we're doing that. But we don't need to do any of this math down here with the bottom add item to stack. That's just going to be the remainder is going to be the amount to add. And the item stack index will still be the source slot. So that will be the index from the top one here. And for the right click, you also don't need to do the true path, the second set element, you don't need to do either, because this is to blank out the original slot. And of course, we don't need to do that because that's already dealt with by our right click operation. So we can delete that one as well and immediately go into call on inventory changed. And of course, we need to hook up these two branch nodes. So the branch node for left mouse button, if it is false, it's going into the input for this branch node over here, if I don't mess it up. And once again, this looked like a entire mess. We'll make sure that things are a little bit more cleaned up in the actual project files that we will be providing for extra material. So this is the function for merged slots. And this was mostly the painful part of today's video. So let's go into the WBP item slot and actually implement that, shall we? Because last time when we left off here, just to refresh our memory real quick, we just said, hey, if the slot already has an item, just do the add item to stack, which is a function that will put back those items in the stack that they came from. But now we're going to add another if statement to this, or a branch, if you will. And here we're going to check, hey, there is an item here, that's neat. But if that item is actually the same item between the destination and the source, maybe we'll try to merge them first. So if this condition is false, we'll still do the add item to stack. And if it is true, we will use the inventory component to run a merge stacks function. And we'll plug in those parameters in a minute. But first, let's do the conditional check here. We have our inventory stack, which we get from our drag drop operation, in case you have forgotten. And from that, we can just get our item assets and we can just say equal as a condition check. And we're going to check that against our own inventory slots, which we already have an easy to get reference to here, actually, just to see if it's the same item. And if it is, we run the merge stacks. It's just as easy as that. Now, we want to pass through, first and foremost, the pointer event, which we can get if we just go all the way back here. The on drop has a input for pointer event. We can just pass that through easily like that. And then the source slot and the target slot. The target slot is just going to be our inventory slot that we're working on right now. And the source slot will be our inventory stack. Again, the thing that we're getting from our drag and drop operation. This will only do the merging though for the right click version of moving items around. Left clicking still doesn't have any merging. So you can really decide that if you don't want to have the capability of right-click merging or the capability of left-click merging, to just not include either one of those. I don't see why you wouldn't do that. But this is also why we made a single function that inside the function just has capabilities for both left or right-clicking to merge. You can also make those into separate functions. Just put the right-click version here, and then we're going to be adding the left-click version up there. So let's take a look at that. We can just copy over pretty much these same conditional checks up here. And we'll just first and foremost check, add in one more branch now actually. First and foremost, we will check whether or not the slot already has an item in it, which we can do with our target slot has item. Let's just copy this over here just to make this a little easier to work with. We get that off of the inventory stack from our drag and drop. And let's check whether or not this thing has an item. If it doesn't have an item, we'll just run the swap slots function, which is what we've been doing so far. If it does have an item, we're going to check, hey, is there a possibility for merging this? If there's no possibility for merging it, we're still just going to swap the slots. And the way we check for the possibility for mergers, we've done that now a million times. We check this item asset, and then we also get our inventory slot. We split that structure pin and check that item asset as well. And if those are the same, we once again do the same thing. We run the merge stack function off of our inventory components. So we merge stacks. Pointer event, of course, takes information from the input on the onDrop function. And then we do much of the same way. The inventory stack that we pull through is going to be our source slot, and our target slot will just be inventory slot that we have on here. Now there's one important thing that we need to actually update in order for this to work. And for that we're going to go back to onDragDetected. Because as you can see, on the right click drag, we send through a inventory stack in the creation of the drag drop operation that we have here. But we don't really do that at the moment with the left click version. So what we'll do is we'll just put the inventory slot into there. We haven't been using that information up until now, so I haven't connected it up. But right now we're going to be using it, so it is important to have. And that is basically the setup for merging stacks. So let's see if it works. For ease of testing, I'm going to go into my item assets here, and I'm going to go rock maximum stack size like 10, because otherwise getting to 64 is going to take a while. It's going to be annoying. Don't really want to do that. And for this quote-unquote chest that I have here, I'm also going to go in and set the stack size for the rocks that spawn in to something like 20 for both of them. I could just spawn in one with 40. I could. Probably should. Let's test this out. And now we can just pick up the sword, because why not? And then pick up a unhealthy amount of rocks with all my line tracers. And this should really be enough for me to be testing my inventory with. So let's open the inventory, test out. We can still swap around our slots. We can still move to empty slots because that's functioning the exact same way. We can still split stacks like this. But now what we can also do is we can pull a stack onto another stack and it will merge them together, which is very nice. And that just added 5 and 5 to 10. That's a full stack. But if I take this 3 stack over here and put it on this 5, it becomes an 8 stack, which is fantastic. Now, if I pull half of this 8 stack off and put it onto this 5 stack, this will become a 9 stack, even better. Now, if I put this 4 stack and I put it onto the 9, it should become a 10, and this should become a 3. And so it does. So now the last thing that we need to check is if we merge this all together. That's fine, an 8 stack. If we try to go overboard with a split stack like this, so we take 5 out of here, we try to add it to this one, this should be 10, and this should go back to being 8. And so it does. So our inventory splitting and merging now fully works. There's a little bit of iffiness in some of the setup here because of the way we have some of the other code set up. Again, I really do like the idea that when you pull off of this, you immediately see that there's 5 left here. And it's kind of just because of the way we have that set up that left clicking and right clicking operations are dealt with differently. But now that we have all of that set up, we shouldn't really have to think about that anymore, because we can just use these functions in a bunch of different scenarios now. And that's the basics of the inventory itself done. The only things that we really can do now is go forward and add things like dropping items, maybe add things like chests and shops. And we'll do a couple extra parts here to implement those slightly more advanced things, but this is the basic setup for your inventory system. Now that we have a more or less functioning inventory, let's take a step back and do something slightly simpler to really reiterate all of the techniques that we've talked about in the last couple of videos. And then after that, we're going to be moving on to some more interesting stuff with chests and shops again. But for today, we're going to be talking about how a character can drop items from their inventory back into the world. Because at the moment, what we can do in the game is we can pick up items with this line tracer over here, but we can't then drop them back out of our inventory again. Also, I'm going to be anchoring this to the left side of the screen rather than the center, so it actually stays in my view properly. I also made the inventory a little bit smaller and thinner, just to have it look a little bit better. So let's get started on a widget that we can use to make things drop. Let's come into the inventory here, and we're just going to make a new widget blueprint here. So we'll just make a new simple user widget. And we'll call this widget blueprint drop item. Let's get started here with, we're just going to use a size box for now, because that allows us to very easily set the actual size that we want, which in this case will be the same as our inventory slots, I imagine. Maybe a little bit bigger. Let's make this 150 by 150. And then for reference purposes, we're going to put this as desired on screen, so we can actually see how big things are. And in that size box, we'll just simply put an image, and we don't really need to do anything more with it, to be honest with you. And I had ChatGPT generate me a arrow image, which again, much like all the other images here, is kind of bad, but it'll do the trick for now. Then we go into the graph view, and obviously we overwrite the same function that we did on the inventory slots themselves, that is on drop, because we're still working with drag and drop operations here. It doesn't really matter whether or not it is the left or the right mouse button that we have here. The only thing that we really care about is the operation, which we need to cast to our drag drop operation that we've made in previous parts. With that, we can first and foremost delete the item out of the inventory, and then we can spawn it into the world. So let's go back into the inventory component here, which still is a little bit of a mess, don't mind that. And we'll just simply make a new function here that clears out an inventory slot. I think that will just be the easiest thing to do. So we can make a function clear inventory slots, and this will just very simply take our array, set an array element of a certain index to be an entirely empty inventory slot, but it will still have the proper index. And of course, as with everything, we want to call on inventory changed. Now, the drop item. Now, the drop item blueprint is going to need a reference to the player inventory components. And since we're not going to be using this in things like and since we don't really need to use this in context of a enemy or a merchant inventory or whatever, because you're not allowed to be able to drop the things in those inventories into the world, right? That would be just stealing their inventory. Only really relevant to player inventory. We don't need to do anything too drastic about this. We can simply just get the player character, and we can get the inventory from that with the blueprint interface that we set up previously. And we could promote that to a variable, but we're only going to be using this right here for this one thing, so we don't really need to. And we can clear the inventory slots like that. And the way we can figure out which inventory slot we want to clear is we can get our inventory stack, split that structure in, and get the index that we want to clear. And now we'll have a button where if we hover over it in our inventory, it will clear out that inventory slot. But this is just a deletion button. This is not a dropping button. Well, first and foremost, if we copy over this code into a separate blueprint, which will just delete something, that actually works out perfectly fine. So if you want to also have like a recycling bin in your inventory where you can just delete items out of existence, this is simply the way we do that. And we might also make that in a second just to have a more complete inventory. But again, we don't really care about doing all that at the moment. What we want to do is we want to actually spawn an actor from class, and we're going to go all the way back to early on in this series where we made the world item actor, which allows us to spawn in actors into the world. And we want to figure out which item we want to spawn in and how much of that item. And wouldn't you know it, we have that information right here. So we actually want to do that before clearing the inventory slot for what I assume are obvious reasons. Because if we clear out the inventory slot, then the data we'll be reading from whatever inventory slot that we're dragging away is now empty. So we want to spawn it in and then clear it out. So we just drag in the item data asset to the item data asset and the stack size to the stack size. Now for the world transform, we're going to split this one up. The scale will just be 1, 1, 1. The spawn rotation can be 0, 0, 0. I don't really care about that. For the location, we'll get actor location from the player character, get actor location, and to that we're also going to add the get actor forward vector, which will multiply by something like, I don't know, 200 to have it spawn slightly in front of us when we drop it. Otherwise it's going to drop on our head, and that's not really what we want. So let's convert this spin into a float and multiply this by about 200 and then add that to our current actor location, and that's going to be the place where this spawns into the world. Alright, and that's really all there is to that. So let's go back into our player inventory, which again I have changed up a little bit, and in our canvas panel we will add a drop item widget, which we can just put in like this, and we'll anchor that to the bottom left. So let's test this out. We can collect a couple of rocks here, that's all fine. Let's also collect the sword, because why not? We have it in our inventory, we can drag it into our drop button over here, and then it spawns it into the world, clearing out the inventory slot. Now the real test is, does it have 2 rocks inside of it? 1, 2, and it's back in our inventory. We can drop the sword, and it works much the same way. So we can now also drop items. As a little bonus here, because this is a pretty quick and light episode, we're also going to actually do something that I wanted to do quite a while ago, and that is make this thing have a border when we're hovering over it, just to make things look a little bit better. So we'll go into the item slot, into the event graph, and we'll actually select the button that we've added. You might have been wondering, we haven't been using this button at all. Why is this even relevant? And that is because the button just gives us an easy way to see when something is selected or something is hovered over. And that's what we're going to be using here. It's entirely a stylistic thing. So let's say when we are hovering over it, we will take our border image here, and we will set brush from texture, and we can just select our new texture there. But before we do that, we want to also go back into the button here and say on unhovered, because we also want to set this back to the original image when we're no longer hovering over it. So let's set the unhovered version to our border image, or whatever we call it, inventory slot. And really quickly in Photoshop, I'm just going to add a quick stroke outline around it. It's going to be a little bit bigger than that. And let's make it a nice thick color, like yellow, maybe even a little bit brighter. And something like that should work just fine. So now we have this outline selected version, which we can choose. And we'll see now, as we mouse over this, we highlight the inventory slot that we're currently selecting. Now let's also duplicate the drop item into a delete item. And here we're simply going to go into the graph, and on drop, what we're going to do is we'll just get rid of the spawn actor stuff and only clear out the inventory slots. Which does bring me to one last thing that I want to talk about right now, today. Because if we add this, we can say, okay, delete item, that's all nice. We want to definitely give this a different image, which I also had ChatGPT generate a garbage bin for me. And to make this also work with the controller inputs or just like keyboard inputs or whatever, if you're not using a mouse, what you can do is you can also add the event on focus added to focus path. So that is event on added to focus path for the set brush selected, and then event on removed from focus path for the normal brush again. This way, when a inventory slot is selected as being active, it will have that highlight around it as well, even if you're not hovering over it. So I'll show you that real quick. I changed the keybinds to open the inventory with I, and if I just select something here and I make this the active window, I can tab all throughout it. It still has the blue outline around it. That would also show that this is currently the selected slots, but we also have our own yellow outline on it now. So that's neat. And if you do this with the arrow keys, it also works fully well, and so forth and so on. Same with if you have controller bindings for this, you can now navigate this with the controller fairly easily. Of course, you would also need to set up some drag and drop functionality for your controller, which we haven't done here, but that is kind of the same as we have done, but instead of using mouse events, you would be using key input events instead. And one last thing that I want to show is, in general, if you do like a left click operation and you let go of it anywhere in the screen that doesn't have any like on drop functionality, so anywhere at all, nothing happens. But since we already remove the split stack at the moment we start splitting them, if I cancel this operation by trying to drop it somewhere that it doesn't have a drop location, it doesn't add them back into the original slot either. That is something that we didn't cover in the stack split video. And since this video is just a little bit of adding things and polishing things up, let's do that here as well. So in our item slot over here, we can also come into the functions and we can see when. As a quick correction on a part of the video that I don't know how I'm going to cut this yet, but what I did in the original recording of this video for this section is in the item slot, I made this little function over here, which was supposed to prevent splitting stacks and then deleting items accidentally when dropping it outside of a window, and that didn't end up working out too well. So instead what I ended up doing, and I'm just going to go through this after the fact, I made in the event graph for the item slot the wait for drop event, and all that does is it binds to the on drag cancelled on a drag and drop operation. So the parameter here is a drag and drop operation. I'll just call this DDO. Then on drag detected, if that is a right click drag, what that will do is it will pass through that drag drop operation to wait for drop. And this will then fire. And then that means that whenever we cancel a drop, so whenever our drop ends, this new custom event will now fire, which will of course cast to our custom drag drop inventory slot thing that we made, in which I have made a new variable for success, just a boolean, that will test whether or not we successfully dragged and dropped into another inventory slot. If we didn't drag something into an inventory slot, this will stay false, and that way we can check whether or not we should restore things to their original slot or not. So here we check whether or not this is a success, and if this is not a success, meaning that we release the button outside of any relevant window, what it will do is it will take the inventory components that we took that from, and on that run the add item to stack. And since we are just passing through our drag and drop operation, much like we do in all of the other code in this system, we can simply get the stack that we were trying to add to something and add it back to where it came from. and then I unbind that event again until the next time around when we do a drag and drop. Then in the onDrop function we have here, all of the paths end up leading to setting the drag drop operation that we get pass through to setting the success value to being true. Also, what we should probably do is in the drop item operation and the delete item operation, we also need to go in and set the success value to being true. I had not done that yet. I just wanted to jump in and record this little correction right away because I'm going to be editing this video soon and I wanted it to be in there. So again, in the delete item, we will also jump in on drop. We will make sure that we set success to being true. This is just a value that we can now look at when we finish a dropping operation to see whether or not we actually dropped it into some kind of other UI element or if we let go of it in the middle of nowhere, in which case we need to reset it. Once again, this is entirely because, I'll just pick up a couple of items. This is entirely because of the way that I decided that when dragging and dropping with right click and splitting the stacks, I immediately want the number on the bottom right here to update on the old stack, meaning that I already am deleting items out of it. If you don't want that, none of this really is an issue, because if I try to do this with a left click, it simply doesn't do anything when I drag it out of it. But now, when I do this with a right click, it also restores it to the slot that it came from. So that's very, very good. Because we're clearing the inventory slot from the index, what we should be doing, we should only be clearing the inventory slot if it's a left click operation, which is kind of annoying to deal with. So, it's not that big a deal though, because we can of course get the affecting button and we can check if the affecting button is a left click, in which case clear inventory, and otherwise do not clear that inventory slot because we've already subtracted what we needed to subtract. So this is a little bit of a messy video altogether, I'm aware. Let's also do that in the delete item while we're at it. And also make sure that the success value here is set to true. But every so often you just need to go over your code and test things out and refactor some things and make sure everything works. So I kind of guess that this episode reflects that part of coding as well. So again, get the affecting button, check whether or not that is equal to a left click, in which case do the clear inventory. For right click, don't do that. And we still want to probably hook this up onto the return node just to be sure. And we set that to true. I don't really think it matters, to be honest with you. At least not for our purposes, but we might as well. So now we should be able to delete half a stack without deleting the original stack there. And the same with this, we should be able to drop half the stack without it deleting the original index as well. So everything works now, and once again I can drop things outside of this window and they will just return to where they came from. A little bit of a extra update at the end here after I recorded the initial bit and I was working on tidying some things up and I figured out a couple of bugs that I needed to fix still. So hopefully this helps and isn't too confusing added on to the end of the video here. Now, last time we did a lot of tidying up of our code in certain ways. The blueprints still look like a mess. I'll work on that later. And we now have a more or less functioning inventory here, which has a highlight selection, it has a delete button, it has a drop button. We can pick up some items, but as you could see, the thing that I just did there was opening a chest, quote unquote. And I don't know, that's not usually how chests work. They don't just explode items into the world. So that's what we're going to be looking at today. But as you can see, everything works as you expect an inventory to work. This is what we've been making so far. Today, let's actually make this chest into a chest rather than something that just barfs items into the world, because that's not really what we want. To get started here, first things first, I'm going to put this inventory slot image into a different folder. And we're going to just copy over the player inventory, really, because what we're going to be doing is a slightly different version of the player inventory. So we'll call this WBP chests inventory. And when we open that up and put it into our tabs here, we'll see that we have the player inventory as we're used to. For this version of everything, I don't think we're going to necessarily need the delete or drop button. It could be useful to have that in a chest to be able to take things out of the chest and drop them into the world, but if you're going to do that, you might as well just keep them in the chest, right? And the same thing with deleting them. There's no real use to having these around, so let's just remove those. And that allows us to make the inventory for the player a little bit larger. Then we'll name this item grid player because we need to display 2 item grids here, 2 inventories that we're going to display. So let's duplicate this one over and we'll put that on the other side of the screen, roughly in the same position, and we'll anchor it to the right side of the screen. It's probably not going to look very good right now, but this is mostly about functionality and not visual design. And this one we'll call item grid chest. Now, going into the graph, we need to set up a couple of things, because usually we have the player inventory component and the and such all being set through spawning the thing in. And that's still going to be how we set the inventory component for the chest, obviously. But for the player inventory component, we don't have to worry too much about it, because that's always going to be the player. The way I showed you before is a more generic way to pass through information and references from parent to children and whatever, which we're still going to be using. But for the player itself, what we can actually do is we can set the player inventory component value through a very easy method, and that is just getting a set node, and we'll get the player character. And since we made a interface to get the inventory from any object, really, right at the start of this series, we can very easily just get the inventory from the player. If you want to make sure that it is a valid object, you can put a isValid node in here. I don't really care, so I'm not going to do that. And that way we can get the value for the player's inventory component into this very, very easily. Now, we could have also done it this way in the actual player inventory, and you probably should do it. But I just wanted to show you the way to pass through that information from layer to layer to layer. Because otherwise, I would have to explain it at this point, and there's plenty enough that we're going to have to cover in this video. Now, that said, we do need to also make a chest inventory component, which is of course going to be of type inventory components. This one we will set in much the same way, so we're going to expose on spawn and set this to instance editable, and then the player inventory component is actually not going to be exposed on spawn or instance editable for that matter. And here we have the item grid for the player being set by the player inventory component, which is exactly what we want. So we'll copy that over and get the chest inventory component, and there we will try to set as the value for the grid that the chest is going to use. So in here we can then also set inventory component, because that's a variable on the grid that we need to populate, and that'll do what it has to do. Whenever we construct this thing, of course, we are also going to immediately do a first update for the player grid, and you guessed it, we also need to do that for the chest grid. So we can just copy over this node, link this all up, and that will do just fine. Now, if we go back to our chest blueprint and open it up, we also have like our interaction interface on here, and we set that to just spawn in the items inside the chest. Of course, that's not what we're going to do anymore here. So we'll delete all of the code that we put in here in the first place. We also have a return node just hanging out somewhere. And in its events graph, we're going to go back here to begin play, because on begin play, I actually want to create the widget right away. And of course, the widget that we're going to create is the chest inventory, because I want to set the chest inventory component value right off the bat. And then we'll promote this to a variable, and we'll call this chest UI. Because now we can go back to onInteracted, and we can just get this chest UI and add it to the viewport here. So we can add to viewport, but the UI element will always exist on the chest. We'll only add it to the viewport when they become relevant. This is not, technically speaking, the most ideal version of it, because now every chest is always going to have its UI loaded into memory ready to be displayed on the screen. These UI elements are so negligently small for your memory footprint that unless you have a ridiculous amount of chests, it's not going to matter, and it does make this just a little easier to deal with. Now, whenever we put it on the viewport, we also want to make sure that we have the most up-to-date information on the inventory. It should display the most up-to-date information on the inventory, but it can't hurt to make an event that specifically does that. So what we'll do is we'll make a custom event in the chest inventory blueprint, and we'll just call this updates item grids. And that will just go into the same thing as the event construct. We can just run this manually to make sure that everything has the most up-to-date values in them. And we can just run that from our chest UI reference. So we can just update item grids just to be sure. Now, then we want to set our input mode to UI only. For that, we need to get the player controller because, of course, set input mode to UI only. You can also set this to gameplay UI. It really depends on your own game. And the widget that we want to be focusing on is our chest UI widget. And we also want to make sure that our set show mouse cursor is set to true, because we're going to be, well, mousing all around the screen trying to do some inventory management. So set that to true. And that should now allow us to open up this chest and see its inventory. And we can even, within the inventory itself, move things around. But what we cannot yet do is drag this from one inventory into another. There is a little bugginess if you try to split it into this inventory. That does work for some reason. I have not programmed anything in for this to work. It just straight up works. I'm going to be real with you. I'm kind of confused as to how this works. So let's get working on that. And for that, we're going to need to revise a fair few functions that we have made on our inventory components to take into account not only moving things around in one inventory, but also have a sense of a source and a target inventory. So let's open up our item slot just to see our graph here with all the functions that have to do with switching items around and moving items and whatever. Because all of those are going to now need to also have an input for a source and a target, or at least most of them. Let's start with the most important function, which is the swap slot. This is just the left click, dragging an item into a different slot. And if we open that up, we'll see that, again, this is a quite simple function. Let's go and add some parameters to this, shall we? We want to add a source inventory, which of course will be a inventory component. And then we'll also add a target inventory, so target inventory. Instead of just using the array from this side over here, just dragging that in, what we're going to do is we're going to take the source stack from our source inventory. So we want to get the inventory array on our source, and that's going to go into this getting node instead. And much of the same we're going to do down here. We're going to get our target inventory. We'll find the inventory array in that and use that instead in this getting node. So no more simply dragging and dropping this from the sidebar, because now we need to be aware of the original inventory and the inventory that we're putting things into. Same thing goes for here. This is just both using the normal inventory array that we have, but we want to put the target stack into the original source inventory and the source stack into the target inventory. So we'll take the source inventory, the array, and we're going to put that into the first node here, the thing that is setting where the target stack is going to go. And we'll take the target inventory array and put that in the other set array element. Now, it's also important that we do the call on inventory changed properly, because this is just going to call this on the inventory component that is being run on itself, but it should actually execute this on both of the inventories. So it should execute this on the source inventory, but also on the target inventory. And now that we have that set up, we can go back into our item slots and we'll see that our swap slots function now has 2 more pins in it. How are we going to get the information to put in those pins? Well, that's remarkably easy for both of them, actually, because we already have a inventory component on our item slot, and that's just going to be our target, because this is the thing that we're dropping on top of. The source inventory component is actually also really easy, because if you remember back all the way to when we make this drag and drop operation, I added in a source inventory component as one of the values here, and up until now we haven't really used that, but I knew that we're going to get to this point and we were going to need to use it, so I included it right off the bat. Going back into our item slot on drag detected, you will remember that we put the inventory component into the drag drop operation that we created. So this is taking the inventory component from the item that we're taking and passing it through the drag and drop operation, so that when we eventually drop it back into another slot, we still have that reference to the slot that we've taken from. And that means that we, on drop, simply can go back to our drag drop operation and we can get the source inventory components. And it's just as easy as that, plugging that into our swap slot. So that's the basic setup that we're going to have to do for more or less all of these functions, but let's just show off the fact that it works first here in this. So I can now take this from this inventory and put it into this other inventory, and I can just swap these back and forth as much as I want to. So now let's take a look at some of the other ones. We also have the put a new stack, the add item to stack, and the merge stack functions. Now that we've gone over these are going to be somewhat more simple. The put in new stack will just take in any inventory array and put an item into an index in that array. That's quite fine. This doesn't even need a source and a target. This only really needs a target. And as such, we don't actually need to put any new pins into this one. So that's fantastic. Add item to stack. This one, however, is also used to add items into a stack potentially in the chest, because we're also using this in the right click drag and drop operation. So this one does actually need to have a source and a destination. So let's add in our source inventory specified, and for that we will get the inventory array, and we'll just replace this reference here with the reference from our target inventory, which then also needs to be updated with on inventory change. Going back into our item slots, we now have add item to stack here, which will be in our target inventory. So we can just get our inventory component from our variables and put that in there. That only leaves the merge stacks function, which, if you recall, is a mess. I probably should have cleaned this up before starting this video, eh? Well, it's a little too late for that now. So let's take a look at it. We need to have a concept here of source and target both. So we have the source inventory, because this blueprint wasn't confusing enough as is. Don't worry, as I've said before in other videos, by the time the project is finished and everything is up for Patreons and YouTube members, this will all be a lot neater and a lot more organized. The episode by episode uploads that I'm also doing for these project files, they're going to be messy. The final one is going to have more reroute nodes, going to save things as variables so that they're a little bit easier on the eyes. They're going to be commented and all that. Anyway, we have our source inventory and our target inventory now. So let's take a look at which ones belong where. This first one here is setting the targets. So let's get our target inventory, because this is the slot that is getting the new items. So get inventory array. So we can replace that with the target. And then this one is clearing out the original slot that things came from. So that's going to need to be taken from the source inventory slot. So get inventory array from the source and clear that out here. And in much the same way, we need to use the target inventory, which is this one, in this bottom set array element down here. And then we need to add items to stack. That's the function that we just changed as it was. That now has a target inventory. And the target inventory here is going to be the source inventory. And that might sound like a confusing sentence, but let's just think about what is happening here. We are setting some items to the new inventory slot, and everything that is left over is getting put back into the inventory slot that it originally came from, otherwise known as the source inventory. So we take the reference to our source inventory and put that into the add items to stack function here. And then down here we have something very similar going on. So we want to pull down this reference to our source inventory slot into the add items to stack as well. And then these are both going to be our target inventory slots. So that will be our target inventory, and we'll get the inventory array out of that one as well. So as you can see, a lot of what we're doing right now is just retrofitting existing code to work with multiple inventories, and not so much doing new code. And with that, we can go back into our item slot and also put in the proper values for the merge stack. So the target inventory in both cases, merge stacks is in 2 locations. There's the second one, is going to be just the inventory component reference that we have in our variables. And the source is going to be the one we get from the drag and drop operation, the thing that we pass through when we start the drag and drop operation. So now that all of that is lined up, our dragging and dropping between inventories should just straight up work. So let's open up our chest and see, okay, we can drag and drop this over, and then we can drag and drop half of it back over to there, and that works. Drag and drop half over to there. And as you could see, actually, I didn't even mention this before, but because we set up that chest to have 2 stacks of 20 in it, you can very easily set up chests and generate chests that are more compact than you as the player can actually do, because it just generates those stacks of 20, and then when you pull those stacks of 20 apart, you can't recombine them anymore because of how we have things set up. So if you want to have like a uber chest where the player has to start choosing what they do and do not take, that might be an interesting way of doing things. Just adding like stacks of like 100 gold coins in every single one of these slots, and gold coins only stack up to like 50. So you can only take half of them at a time. Just very interesting opportunities for your game design. Anyway, we can just inventory manage between these 2 inventories. The last little issue here though is that we still can't exit out of this inventory because our player input is getting blocked because we're setting this to UI only mode. So let's get back real quick, and the easiest way to just fix that is just adding a simple button. We'll add a button and we'll add that to the bottom middle anchor, and we'll just add in a little bit of text that just says close chest or something like that. Close chest, and probably make this black color so that it's more readable. And then when we click this, I'll just put that down here somewhere. We can do the onClicked event, and what this will simply do is it will get the player controller. It will first and foremost set the mouse cursor shown to false, and it will set the input mode back to game only. So input mode game only. We can flush that input so that the game itself doesn't pick up on that click in case we have like a attack set to our left click action or whatever. And after that, we simply remove this widget from parent. So that's going to remove it from the viewport. And with that, we have a nice chest that we can very easily close again, and we have control of our character. And you can just add your own items to these chests as well. I mean, that should be obvious, but I just want to show you. And if I take some items out of it, I close the chest. It's just an inventory component that is going to survive as long as this object is alive. So if I open up the chest again, the contents still are the contents that we left in them. Now, if you're streaming this chest in and out, of course, you're going to need to put that into a save data object, but that's not really what this tutorial series is about. And I'm going to assume that you know how to either save data or carry over data into like the game instance or whatever. But this is how you make a chest functional for your game. So with that, we only really have one more important thing that I really want to do, and that is making a shop for you. because a shop is kind of like a chest, but slightly different. To finish off this inventory series, let's make something like this. A shop where we can say, hey, I want to buy a certain amount of items, and then it subtracts them from this inventory and puts them into this inventory, and we can select any slot in either inventory that we want to either buy or sell things, and we are not allowed to drag and drop within these inventories. We're going to split this up into two parts. One part is going to be the setting up of the selection of the inventory slots, and then the next part is going to be the actual buying and selling mechanic. Since this is the last thing that we're doing in this series, there will be only one link down below in the description, which will just be the finished project, which is up for download for YouTube members and Patreons. Doing a per episode upload for this one doesn't make a lot of sense, because after this we'll be finished. And I'm not going to be uploading half a progress update. So let's get started on making the shop inventory. The easiest way to do that is to use the chest that we have made before and duplicate that to be the basis for the shop, because we need 2 inventory slots just like we do with the chest. Now, in the shop itself, we're not actually going to be doing that much different here today. That's mostly going to be the next part where we do the actual shopping calculation stuff. So let's open up the other classes that we're going to be working in today as well, which will be our item grid, our item slots, and we'll go back into our content folder here and open up our inventory component as well, just in case we need it. Again, don't mind all of this mess in the project download that will be down below in the description. This will all be cleaned up and much more neatly organized. So first things first, coming into the item grid, we're going to be adding a couple of variables to this. And number one will be allow drag. This will tell whether or not we're allowed to drag and drop within this inventory or not. Then we will do allow select, which does something similar, but for click selecting. And while we're at it, we might as well also make our selected index variable, which is going to keep track of which inventory slots we have selected in this inventory. That will of course be an integer. Because once we have done that and we go back into our shop, what we can do is we can select these item grids that we have in here. And now we'll be able to see that we don't want to allow drag, but we do want to allow select. So let's set allow select to true for both. And now that I think about it, it's probably a good idea to set allow drag to be true by default, because most of the inventories we do want to be able to drag and drop around. So we set that to true by default and then select them to false in our actual shop window here. But those values in and of themselves aren't going to do too much. So the way we're going to use the allow drag bool, let's do that first, is coming up into our item slots, which is this widget, if you remember correctly. Into our graph, we're also going to add in a allow drag into here, which will also be a boolean, which this one will be exposed and also exposed on spawn, because we're going to be setting this every time we spawn one of these in. Then coming into our mouse, on preview mouse button down, this is our drag and drop operation starts here. With either left click or right click, this is how we start our drag and drop operation. So let's get our allowed drag and put this into a branch node. And only if we are allowed to drag in this item slot will we start our drag and drop operation to begin with. If this is set to false, we won't even bother setting any of this up, because we're not going to be allowed to drag and drop anyway. Now, with allow drag being an exposed on spawn value, we can come back into the item grid here, and you can already see that allow drag is now one of the pins. If it's not, what you can do is you can just refresh node and it should show up. So we'll simply set allow drag to be equal to the allow drag of the item grid itself. So now every time a item slot spawns in, it's going to copy over the allow drag value from the grid that it spawned inside. And we can quite easily test this out if we were to make a shop. So let's also do that for testing purposes. We can just copy over the blueprint for the chest, because it's going to be very, very similar. So let's call that blueprint shop. And in the viewport, just to differentiate them, I'm going to set this to the same material that I did in the preview at the beginning of the video, the hex tiles. You can do whatever you want. Realistically, this would be an entirely separate static mesh. But in the event graph, we, instead of creating a chest inventory widget, what we'll do is we will create a shop widget. And then the chest UI variable that we have here will also change over to a shop widget variable. That does make a couple of nodes in another function misbehave. We'll worry about that in a moment. We can now reconnect these up, and just to keep things tidy, let's rename this shop UI. Coming into our interface here, on our uninteracted, we have this node here, which is trying to still use our shop UI and our chest UI and everything, but it's not really going all that well. So let's remove that and re-import it. We can just add to viewport, that's not a problem. This one we won't be able to connect up because it's trying to run a function on the chest widget class, which this is not a chest widget, but our shop UI has the exact same function, so we can just run that. Don't forget to put the widget in focus to be our shop UI, and then everything should now work. So we have our shop interactable, and we can, if we just open this up a little bit, create an inventory component, which we can just inventory constructor. We can like add a rock to it, and let's say stack size is 20 for this rock. Pick up the sword as well, why not? And if I go into this chest over here now, you can see that we can't drag and drop these items around. If I close chest, this will be called close shop in a moment. Go into my own inventory, here I can still drag and drop them around. So we've now disabled dragging and dropping on only the shop, because again, in the chest, I can still drag and drop all I like. Now, dragging and dropping has been disabled in the shop, but now we need to enable the selection, the left-click selection of the slots, like I showed you in the beginning of the video. And that's where the real stuff gets started. So let's get into that. And the place that we're going to start that off is in the item slot itself, because obviously we need to be able to click on these things to make them selectable. And this is one of the reasons that we started out way in the first few parts of this series with a button on this UI, so it's clickable easily. We've already used the button behavior to make it display a border on hovering over them. Clicking is going to be the other thing we use this button for. So select the button up here and add a unclicked event, and we'll just pull that up to be in the same area as the other two button related events. And all this is really going to do is it's going to call an event dispatcher. So let's make one and call that on button pressed. And let's just add a call to that. Now, so far, all of the event dispatchers that we've used just send out a message that they have been called, that the button has been pressed in this case. But now we actually need to send through information to everybody listening in on that as well, which is interesting. So you can actually make event dispatchers use the signature, which is just the set of parameters from any other function on this class or any other event. So let's make a custom event, and we're not actually going to be adding any code in this. We're just making this custom event to have a signature to copy from. So we call it like on selected or something like that. And here we just add in a input. We'll call that index, doesn't really matter. Will be an integer. Now, you probably want to compile this, and then coming back to your event dispatcher, you can choose the copy signature from, and there we can find somewhere in here on selected. And the moment I press that, you'll see that on button pressed, that call now has a integer parameter to go with it. Now, the integer parameter is actually pretty easy to get a hold of because we have the inventory slot value, and we can split that structure up in, and that just has an index. We put that in somewhere else in the code, so we already have easy, quick access to that. And while we're in this item slot, we also want to do something else, because we've got these two little hover things, on hover and on unhover, which create those little yellow borders around our item slot image. We only want to do that if this is not currently the selected item slot, because if it is a selected item slot, we're going to put another border around it. and we don't want that to be overridden by the yellow border, or when we move away from it, to be just the default inventory slot image. So what we'll do is we'll also add a variable here, a bool, called simply isSelected. And we'll use this value in a couple of other places as well. And simply what we're going to do is we're only going to allow these set brush from textures if isSelected is false. So if it's an unselected slot, it will display those yellow borders or no border at all. If it is a selected slot, we'll just ignore everything to do with this because it's going to have a different border to begin with. And that'll be it for now for the inventory slot itself. So let's go back to our item grid, because this is where the interesting stuff comes in. We want to go on our update item grid here and move things around a little bit, because we're going to be putting some extra stuff in between there in a moment. We also want to find our event construct, which is down here, and move that into a place where we also can start adding some more stuff to it, because we're gonna need to in a moment. So in here, we want to check if we're allowed to select slots in this inventory. You will note that I have two different bools for allow drag and allow select. Realistically, that could be one bool where you just check, hey, if we're allowed to drag, do the drag functionality. If we're not allowed to drag, then we'll just add in the select functionality. For ease of reading, I made this into two bools, but do be aware that you probably can get away with just doing this as one, because you're hardly ever going to want an inventory where you can both drag and drop and also select slots, because those things are probably going to clash anyway. If allow selected is false, we just immediately move on to add child to wrap box. But if that is true, we actually want to put in a little something else. This thing here creates a item slot widget, and we've just made a event dispatcher on that, so we can assign to on button pressed, which will immediately also make us a event to go with that. And you will note that the event has the index parameter, just like the signature we gave it. And this is an important thing to realize. We can just add a different custom event if we want to, but we won't be able to add that to this event dispatcher because it doesn't match the signature. We need to have it match the signature. So we need to have a integer parameter, and when it matches that signature, we can then assign it to that event dispatcher. That is quite important to realize. And we'll just hook that up if allow selected is true, which means that this blueprint is now going to look out for every single on button pressed event on every single item slot. And whenever any one of them triggers, it's going to run this event with the corresponding index number. Now let's get our wrap box. And from that, we can use the getChildAt function, which takes in an index and returns us the widget element at that index. So naturally, we want to get the child at the index that is being passed in, but we also want to get one of these where we get the child at whatever is our currently selected index, because we need to turn on anything related to being selected on the thing that we just pressed, but it also means that whatever was selected beforehand, we need to turn things off on. So both of these are going to need to be cast to WBP item slots, because that is what these are going to always be anyway. So let's add two of them, one for the thing that we just clicked on and one for the last active. And here we want to, for both of them, get the image border that we added to it, as well as a set is selected node. So what we'll do is we'll set is selected to true for the thing that we just clicked on, and we will set the border with a set brush from texture to whatever brush you might have for the selected highlighted. I have a new separate image for that, which is inventory slot 3. And that is just the same inventory slot again, but this time with a pink reddish border. So let's connect all of those up, and then we'll do the same thing for the second item slot. Again, the item slot that was the last active one. And we'll actually do that first. And the reason for that is in this, we want to check first is selected. We only want to turn this one off if it was selected to begin with. If it wasn't selected in the first place, of course, we don't want to turn it off. So if selected is false, we immediately go into just turning on the other one. But if selected is true, the first thing we do is we set is selected to false, because that's what we're doing here. And then we'll also get the image border from this one. So get image border, and we will set brush from texture, and this is going to set the brush to the normal inventory slot unselected texture. And once it has done that, it's also going to move on to setting the other one to being true. Once we've changed all of these things, finally then we can set our new selected index to whatever thing we just clicked on. So add a selected index setting node, and we can just set that to whatever inputs this event has. Once everything has been updated, we have the newly selected slot, then we're going to need to recalculate how much our potential transaction is going to cost. And we're going to make sure that we aren't trying to buy more items than are in stock in the shop, that kind of thing. So we need to recalculate those things. So we need an event dispatcher whenever we select a new slot. So we'll say on new slot selected, and for this one we don't really need any parameters, so no signature need to be copied. We just need to call this event dispatcher for future use, and that really should be all there is to it. So let's open up the inventory here and see, can we select slots? We definitely can, and we can easily select slots in either of these inventories. So that is the most important basics of selecting slots in the inventories that we can use for a thing like a shop. Now, next time we're going to use these selected slots as a vital piece of information in calculating the transaction value and actually transacting those items and the money involved, which we don't even have money yet in the game. But that's an entirely separate thing in and of itself. So next time, the final part of the inventory series, and then we'll finally be finished with all of it. This project up to date to this point, as well as the finished project where everything is commented and cleaned up as far as like blueprints go, will be down below in the description for all of the patrons and YouTube members to download. We are finally up to the end of the inventory series. Last time we made inventory slots selectable in specific inventories where we allow selection, and we disallowed drag and drop operations in things like this because we are making a shop. Today we're going to be rounding up the entire series by making the shop into an actual shop where we can buy and sell items to this shop to make a fully functioning item system. Now, the first thing we're going to need to add here is number one, a value for money. That's actually the easiest thing because that's just adding a variable. And number two, we need a way to count how many items we're going to buy or sell. Because obviously we don't want to just, every time we click on a button, sell only one item or buy only one item. Because if you have a game where you want to buy like 1,000 ammo at once, something like that, you don't want to have to click that 1,000 times. You want to be able to set the value in like a little box and then buy in bulk. So first things first, going into our inventory component, this is going to be very, very easy. We'll just make a variable called money, and that will be a float value. Why a float value, you might ask? Because float values are usually nice to calculate things with. We'll display this in integers, but behind the scenes it will allow us to have like half a money, which is usually quite nice because it allows you to divide a little bit easier and that kind of stuff. If you really are insistent on making this an integer, you can. Usually I only use integers for when I'm like counting indexes and stuff. Everything else is just a float. But the more important part is making the shop counter. So let's go into our inventory items and make a new user interface here, which will be a user interface. Call that WBP counter because we're going to be counting things. It's just that obvious. And we'll drag this over to my main monitor and start off by adding in a overlay. An overlay because we're going to want to add in a couple of different elements here. Not least of which are going to be 2 buttons. You might want to make this more buttons. You might want to do this in a lot of different ways. We're going to do this with buttons because it's the easiest and most straightforward way to do it. So we'll add 2 buttons, one for increasing the amount of things we want to buy and one for decreasing. Again, you can also make this like 4 buttons. 1 button for increasing by 1, 1 button for increasing by 10, 1 button for decreasing by 1, 1 button for decreasing by 10. Make it 6 buttons, also add the hundreds or the thousands or the 10,000s. You can make this as much as you want. We're going to go for 1 and 1. So this will be the increase button, and this will be the decrease button. And for the decrease button, we want to align this one to the right side of the overlay. In between, we're going to put a little bit of text, and that text is going to display the amount of items that we're trying to transact. So let's align this one to the middle and also make sure that the justification for it is also center text aligned. We'll set the preview text to 0 because it's going to be a number, right? Then we can open up the graph here and add a variable simply for the counter, which since we're counting things, I just talked about this, it's going to be an integer. And we'll also add a value for the maximum that we're allowed to count up to. Because if we are hovering over, or if we have a item selected that only has a stock of like 20, we don't want to be able to set this up to like trying to buy 50. Because dealing with that on the moment where we press the transaction button is a lot more bothersome than just preventing people from getting that far in the first place. So let's add events for both of our buttons. This is the decrease button, we'll add onClicked for that, and for the increase button we'll also add onClicked. And for both of them we're going to just get our counter, and for the decrease button we're going to do minus minus, which is decrement integer, and for the increment button I think you know what we do plus plus increment integer. Now this is where the max value comes in, because we're also going to then try to clamp that integer between a value of 0 and the maximum amount of items that we're allowed to have at any given time. The output of which we'll use to then again set our counter value, because that's how clamping works. So we just hook that both up from both events into this setting node, which is hooked up to this clamping node. And that is kind of everything there is to it for now. And then we want to add an event dispatcher just to let the rest of the UI know that, hey, we just updated something, you might want to recalculate some prices and stuff like that. So we add an event dispatcher that's called onCounter updates. And we simply call that at the very end here. Quick PSA, I'm halfway through this video and I figured out that I actually aligned these two the wrong way around. So if you get confused at any point in time, that might be why. If you're following along very precisely. Increment button on the right, decrement button on the left. And then we can set the text here to just bind to the counter value. So it will now always just display the counter value. Now with that we can go back to our shop and start adding in those counters. So we have the WBP counter for this side, and then we'll also probably want to actually anchor that to a decent spot as well. And then we'll add one on this side as well. So we'll have one counter for buying things and one counter for selling things, just because I like it that way. You can have one counter for either, just because it makes things a little bit easier to program. Let's give these things names. The one on the shop side we'll call counter buy, because we're buying things from the shop, and the one on the player side we'll call counter sell, because we're selling items to the shop. Now we also want to add in 2 buttons for the actual transaction. When we decide, hey, this is the amount of items that I want to buy and or sell, we want to have a button to press. So let's add in those with the proper anchoring as well. I'm kind of adding these very just eyeballing their position. Obviously you want to set these to be a little bit more neatly organized if you're doing this for your actual game. Both of those buttons I'm also going to put the text in, because the text that we're going to put in here is going to simply display the value of the transaction that we're about to do. You can place this on other places on your screen if you want to. I like just putting them in the button. The display preview is just going to be 0. We want to align this at the center, and we'll do that for both of these buttons. Now, there was a lot of UI setup. Now we can finally go into the graph and start doing some programming. So we have this event construct, and really what we're going to do there is we're just going to be binding to a lot of the event dispatches that we have set up. So let's move these update item grids a little out of the way for now, because what we're going to need to add in is our boy counter and our cell counter. And for both of those, we need to assign on counter updated. And that will make on counter updated event. Let's also call this specifically for boying. And we'll do the same thing here. Assign on counter updated cell. And that will create our events that run every single time we update those counters we've just made. So every single time we're going to increment or decrement those values. What we want to do is we want to recalculate a couple of values that we're going to be making on this blueprint. And after those, we still do want to update the item grids and such. So do keep in mind you want to reconnect those up. Now, for this, we're going to make two variables. The first one will be our boy price, which is the price of the items we currently have selected multiplied by the amount of things that we're trying to buy. So that will be a float, naturally. And we'll also make a corresponding value for the sell price, which will be used for the exact same thing. So whenever we update our boy counter, we're going to update our boy price. And the same thing for our sell counter and our sell price. And now we just need to calculate those values. And luckily that's actually remarkably easy. So let's move this stuff a little bit out of the way and get our stuff set up. So we have these components up here, which is our chest inventory component. We probably should rename this to shop inventory component because we're working with a shop now, not just with a chest, but we'll deal with this for now. So let's get this out of here, and we want to get the inventory array that we made on that component ages and ages and ages ago. From that, we want to get a copy of a certain index. We can split the structure pin, and we'll worry about all that in a moment. The index that we're going to be getting will be our item grid for the chest, and there we will have the get currently selected index, which we set up in the last video where we made all of the stuff about selecting the slots in the inventory. That will now give us access to whatever type of item we're trying to buy, and our item class has a value on them that we set up for every single item. So simply we can just multiply that value by the amount of things that we're trying to buy, and we have the boy counter, obviously, and that has the counter value. So we can simply hook that up into there, and that will be our boy price. And our sell price is going to be, honestly, much of the same. So what we'll do is we'll just copy this entire thing over, and we need to only replace a couple of the components. Because instead of the chest inventory components, of course, this is going to be using the player inventory components. It's going to be using the player item grid instead, so we can delete the other one. Instead of the boy counter, of course, it's going to use the cell counter. And just as easily as that, we have both of these set up. Now that we have those, we can actually make these little texts here display the corresponding values. Also, I prefer setting the color for these to black, because they're a little bit easier to read against the gray buttons. We're going to come up here to the text content, and we want to create a new binding. And this is the binding for the cell. So we just plug the sell price into the return value here. It'll create a toText node, which we're actually going to set to maximum fractal digits 0, meaning that we don't want to have any decimal points displaying here. You can enable and disable grouping, which is like the comma or the dot, depending on your region. And we will, of course, do the same thing for the other as well. So we'll create a new binding and just hook up the boy price in much the same way, which we'll set to no decimals as well. And that sets up the price calculations for everything. So now we just need to add 2 more events for when we update which item we are trying to buy. So let's get the item grid for the chest and the item grid for the player. And if you've seen the last video, which if you haven't, you're probably very confused right now as it is, you'll notice that I'll just show you actually, in the item grid, we made a new slot selected event dispatcher. Every time we select a new slot, we call that one. And we're going to be using that now. So we can assign on new slot selected for the boy. And we'll also do assign on new slot selected for the cell. And of course, we need to hook these up into the execution flow. So let's do that real quick. And then make sure to, again, also include the update item grid. When we select a new item, we want to set the max value of the counter corresponding to that inventory. And if that counter was already higher than the value that was allowed, we want to also clamp that to whatever the new maximum value is. And then we also want to update the boy prices and stuff like that. So that's actually remarkably easy. We can start with the chest inventory components and once again just get the inventory out of that. And we've seen this before. We can get a copy and we want to get the chest item grid, get the selected index and put that into this getting node. In short, it's the exact same thing that we did over here, down to the fact that we're going to split the structure pin. But instead of using the item asset, which is what we did this for the last time, what we're actually after here is the stack size. So however many items are in this stack is going to be setting the maximum amount of things for our boy counter. So let's get the boy counter and we want to set the max. And that max will just be the stack size of whatever stack we just selected. And then we also want to set the counter itself to whatever its current value is or the clamped max. So we'll do something very similar to what we did before, and that is we want to get the counter and we want to try to clamp that one between 0 and whatever this new maximum value is, so just the stack size. And that will be our new counter amount. After we've done that, we want to run update prices, but we already wrote that function over here because that's what we do every single time we update the counter as well. But we also can just run that as a normal event. So we can just update the boy price and that will allow us now to select new items to boy. We'll do the same thing with selling. I'll go through this a little bit faster. We'll just copy over the setup from the counter sell thing that we did. And we'll simply copy these over as well. Hook this up to the new event that we made here, which is on new selected event sell. Of course, that's going to be the stack size going into the max, the stack size going into the max of the clamp node. The only big difference is that we need to swap out the counter boy, of course, for the counter sell. We're dealing with the inventory that's going to be doing the selling. And that's how easily we can duplicate that function. We could make this just into like a function that we could use for both of these. Probably should. I didn't. And at the very end here, we want to update the sell prices. And with that, we should now be able to select this thing in this inventory and use our counter to say, okay, I want to buy 5 of them. Well, we've set this thing up way in the beginning to have a value of 2, so it displays a value of 10 here. Now, the only thing that we need to do, and I will just show you real quick if I take items out of this chest as well, the sell side of things works just the same way. The only thing we need to do is to make the buy and sell buttons themselves actually work. And for that, we need to make sure that we select the right buttons. I don't think I even gave those names. So this will be the buy button. And we'll also rename the sell button. Both of those are going to have on-clicked events. So the sell button, and then we have the buy button as well. On-clicked, and for this we're going to make one single function that's just going to deal with all of this for us, because there's quite a lot of node setup to copy over. So for this one I'm actually going to make a separate function. So let's come up here to the functions and we'll just call this buy sell, and this is going to have a few values. So let's get started by making them. We want to have the inventory that is doing the buying, which will be a inventory component reference. We want to have the inventory that's doing the selling. So we do the inventory to sell. We want specifically a reference to the item grid that we're selling from, not that we're buying from. So that will be our grid to sell. And that is going to be of type item grid, of course. So WBP item grid object reference. Then we want to have the corresponding counter for that grid. So we can make a counter, which of course will be of type WBP counter. And then we also want to have the corresponding price. So the amount of money that will be transacted. And that will of course be a float. So that's going to be all of the inputs that this function is going to take. There's quite a lot of them, but that's the exact reason that I wanted to make this a function, because otherwise there's going to be a lot of things all over the place. It just doesn't look good. The very first thing that we're going to do is adding in a branch, because we're going to be checking whether or not the amount of things that we're trying to buy, can we even afford it, right? So what's actually quite nice is that when you make a function in Blueprint, all of these parameters are just accessible as if they were local variables already. So we can say the price, we can just get that without needing to actually get all of these little noodles all over the place, which is just very, very nice. And in the same way, we can get the inventory to buy, because the thing that's trying to buy, we want to get the amount of money in that inventory, because we need to compare that to the price of whatever we're trying to buy. And the price needs to be less than or equal to the amount of money that we have. And if that is the case, then we may progress. If not, you're trying to buy something you can't afford. If we progress, we're going to do a for loop with break. This is very important because we want to be able to break out of it for reasons that I will talk about in a moment. The first index, we're going to set to 1. Usually when you do a for loop, the first index almost always 0. This is one of those rare cases that we're actually using this to count through something rather than using them as actual indexes. So we're going to be using our first index 1 here. And the last index will be our counter. And from that, we're going to get our counter. So the amount of things that we're trying to buy is how often we're going to be looping through this for loop. Now, in the loop body, we want to get the inventory to buy again, and on that we have a function already for add item, and add item is simply going to loop through the inventory and see if there's any spot in the inventory that can take in the specific item that we're trying to put in. So is there any empty slots, or is there any slots that I can merge into where a stack already exists that's not full? And we're going to do that on each loop. So we're going to add these items one at a time to prevent people buying like 50 items in a slot that they can only have like another 10 items inside. We don't want people to like overrule the amount of items that are allowed to stack on top of each other. So we need to add them one at a time. This function already has a output whether or not that succeeded. So if it goes through the entire inventory and doesn't find a single open slot that it can put this specific item into, it's going to return a false. And if it does that, that is where the break comes in with the for each loop with break. And I'll just add a couple of rerouting nodes to make this look a little bit more readable for you all. Now let's back up a little bit because we need to figure out what item are we trying to add. And for that, we use the grid to sell, and from that we get the selected index. Using the inventory to sell, we can then from that, of course, get our inventory array and use a getting node to figure out what item is in the currently selected slot in that inventory. So let's split that open, and that item asset can go into our item to add here. So that is how we get that all working, and let's put this into a slightly more visually pleasing configuration. Now back into this for each loop, if we can add the item, if that was a success, we want to subtract that item from the inventory that's doing the selling. So we want to get the inventory to sell, and on this we're actually going to need to make one last function on our inventory component. So let's make that, and that will be to subtract specific item. And it will just take in an index on which slot to subtract just simply one from. So we can add the input here for that, and we'll just take in a index, make it an integer. And this doesn't need to be particularly smart or anything, because we're always going to just be subtracting from the own inventory. So we don't need to make this compatible with multiple inventory interactions or whatever. We're going to put in a branch to start with. I don't know why I'm typing that out instead of just using B and click. Here we are. Because what we need to figure out is if subtracting 1 means that we just remove the rest of the stack, we're going to need to set the entire stack to just be non-populated so that another item can take its place when the time comes. If there is items left in the stack, we just need to subtract 1 from it. So let's get the inventory here. And we want to, of course, get a copy, use the index for the getter, and we want to split the structure bin because we're going to pretty much be using all of the values in here. First, though, we want to worry about the stack size. We want to check the stack size minus 1, so we subtract 1, and we want to check whether or not that is greater than 0 still. If it is not greater than 0, which means that if somehow somebody managed to buy their way into the stock being negative, this also will just immediately fix that. What we'll do is we will set the array elements. So set array element at the corresponding index here. So that will be the index that we put in for subtract item. And then we're going to split the structure bin here as well. And we'll use the inventory node that we have here. And then we want to set has item to false, item stack will be 0, item asset will be nothing, and the item index for this slot will still just be whatever index that we're working with. However, if this ends up being true, we also want to set array element, but we do need to do a slight bit more work. So let's hook up the proper inventory array for this. The index is still going to be, actually we can just get that this way. There we go, as just a simple node to make things a little bit less messy. So we set the index, we still have has item. The item asset itself is going to be whatever item asset came out of our getting node here from the array. And the stack size will be whatever that stack size was minus 1. So out of the math node, we're going to put that into the stack size here. And then, of course, after either one, we want to call on inventory changed, because that's what we do at the end of all the functions in this component. Now we have a function where we can just say, hey, this index subtract 1 item, and it will do the rest for us. So going back into our shop here, we're still in the buy sell function. We have the inventory to sell. We can simply say subtract item. And we need to pass in the index of whatever item we're trying to subtract from. Luckily, we already have an easy way to do that, and that is just getting the grid to sell selected index. So we can just copy that over and use that as the index for subtract item. Now, after that item has been subtracted, we need to remove the corresponding amount of gold from the item's value from the buying inventory and add it to the selling inventory, which is actually quite easy because we already have whatever item we are trying to transact here through the item asset. So we can simply get the value from that. And then the inventory to buy is going to get the current amount of gold that they have, or money, I think I called it. There we go. And we're simply going to subtract the value from that item from it. We don't need to multiply by anything, because the way we're doing this with a loop, we're moving through these, iterating through them one at a time. So we just need to, every time we go through the loop body, we need to remove the value of one item. And then in the inventory to buy, we also need to set the money then to the new value. So we hook up that new value and we set it. And then in the inventory to sell, we just kind of do the reverse. So we get the inventory to sell. We have a node here for that already. We set the money, and that amount of money is going to be whatever money there already is. So get money plus the value of set item. Now, of course, this can be a little bit more neatly organized, which again, I will do after the recording. Before I upload the finished project, all of the blueprints will be more neatly organized so that if you're going through this as a YouTube member or a Patreon, you'll actually be able to read through what things do a little bit better. And that is the entire for loop. Now we need to just do some stuff on the completion of this loop. And that's just kind of a quality of life thing, because what we want to do is we want to get the grid that is doing the selling, so get grid to sell. And from that we want to get the wrap box and the target index, so the selected index. And what we're going to check here is after we've sold an item, if that item slot is now empty, we want to automatically deselect that item slot, because otherwise we keep having that slot selected and it just looks a little bad, honestly. So we'll just from the wrapper box get child at the index that we just gotten, and of course we will need to cast that to our widget blueprints item slot, and that one we can connect up to the completed pin of the for loop with break. So here we can simply check now if whatever item slot that we're working with, we get the inventory slot information out of that. And if we split that open, we simply check whether or not the stack size is still greater than 0. Because if it is greater than 0, we don't really need to do anything. But if it is not greater than 0, we set selected to being false. And we also, of course, get the image border. At this point, it probably would have been better to make a function on this thing to just set the image border to a certain thing instead of doing this getting of that specific component time after time after time again. But that's something that you can do on your own time, improving the code and workability of things a little bit more than they are right now. But we can set, of course, the brush from texture. And the texture that we can set it to is the inventory slots. Realistically, you could do something with like a enum that's just automatically updating the image much easier through a simple function rather than this roundabout way of doing things. But for now, this will work. And that is the entire buying and selling function done. Now, you can see why we didn't want to copy over all of these nodes and change only a couple of values around for both the buy and the sell version of this. So we just make one function, and whenever we run that, we run it as buy sell. And we just hook that up to both of the buttons and now just have to put in the corresponding values. So when we click the on sell button, the player is selling something. So the inventory to buy is the shop. And of course, the inventory to sell is the player, obviously. The grid that is doing the selling is going to be the player item grid, so that'll be this one, and the counter will be our selling counter. The price that we're going to be working with will be the selling price as well, and that's how easy we can set that up. And for the other button, we'll do the exact opposite. So the inventory to buy is going to be the player, because we're buying something which is getting sold from the shop. So the grid is also going to be the shop one. It's called a chest still. It's because I'm bad at naming. The counter will be the buy counter, and the price will be the buy price. And then after each one of these, we just need to run the on-selected new slot event for the corresponding thing. So we want to do the buy one for the top one, and then on new selected for selling, we do the other way around. That's entirely my bad. So the selling function on the selling button, of course, and the buying function on the buying button. Quite as easy as that. Now, one last thing that I have not added yet is the display of the money on either side of the screen. I kind of forgot to add in the text for that, but that's quite easy. So we can just add in the text. We can just put that on the canvas panel. That's fine. And you can put those anywhere you want on screen, obviously, as usual. So let's put that on the bottom right side here. Align that somewhat decently. Honestly, this is going to not align very well. But making a well scalable UI is not exactly the main priority of what we're doing here. So let's just get it to be good enough and we'll stick with that. Now, the text block here, I'm going to justification on from left to right. And this one, I'm going to do right to left, actually, just because it'll look a little bit nicer. The preview text for both, I'm going to just set at 0. Just looks a little bit nicer than having text block in there. And here we can just create a binding. So this is the amount of money that the inventory component has. So we can just simply say inventory component. So we can just simply create a binding for that, get the player inventory component, get the money. I should point out that if your money is an integer, you can just do this directly without having to make a binding. I'll show you how with the next one. So for the shop one, you can just say, hey, chest inventory component, and it shows up with integers here to display. Of course, our money is not an integer, so we can't do that. So we need to create a binding instead and do it this way. It's honestly not that big a deal, but it's good to note. And also, I do want to make sure that it doesn't display any decimal points. Let's set the default amount of money that an inventory component has when it spawns into like 501. Why not? I made a typo, but let's just pretend like that was entirely on purpose. Let's check out whether or not it displays. So both of the inventories have 501 gold. As I said, they're horribly outlined. Don't worry about that for the time being. And let's try to buy something. So we can select this inventory slot and we can increase the amount of things that we're trying to buy. We buy them and we can see that it adds them to our side of the screen. And we want to buy 7 again. And you see it only has 6 items left in this slot here. And now this maximum amount of items that we can select is 6, which is quite nice. It did seem to deselect things there for a moment, so that's something that might be worth looking into. And as you can see, it had a stock of 20 rocks, but of course rocks we have set to only allow for stacking up to 10. So when it moved them to our inventory, because it's doing it one at a time, looking for the first inventory slot that it's allowed to be put inside, it split them neatly into 2 stacks of 10. And I can of course sell them back to the shop for, at the moment, just the same amount of money that I paid for them in the first place. Of course you can easily set up something where you create a sell price function on the item itself, which then also obviously impacts some of the parts that we're doing here, because now you can't reuse the same function for both of these. So that complicates things a little bit, but I think you, having followed along with all of this, probably understand somewhat how to do that. And the one little bug that we had before with the item becoming unselected is purely a visual thing, I might add, but it is still something that we probably want to... So the little bug there where the item slot got deselected after buying something, it's quite easy to fix. It's because every single time we change the inventory visually on screen, we regenerate the entire inventory. So when we regenerate the entire inventory, we need to go ahead and check for each slot whether or not it is the currently selected slot. And if it is, we need to generate it with the proper border around it. So the way we do that is we, in our item grid, get the create item slot widget, and we get the inventory slot information. And at the very end here, after add child to wrapbox, let's split the structure pin. We want to check whether or not the slot index is equal to the currently selected slot or index. Putting that into a branch node. If it is, we just want to set that to true. And once again, if we had a function made for this, which we probably should have, this would have been a lot easier, but we can now simply just set selected to being true for that one and hook that up to our branching node. And we can use this same strand here to get image for the border and set brush by texture. We've done this a million times by now, so you probably can figure out how to set a brush from texture at this point, and we'll use inventory slot number 3. And that should fix the visual bug with the inventory slot seemingly getting deselected. You will note that the first slot in either inventory is now by default selected. That's because we are setting the currently selected index to being active, and the default value for that is set to 0. Obviously, the 0th index is going to by default be set to active. Honestly, I don't think this is that big of a deal. We just need to make sure that this only happens with inventories that allow you to select slots. So if we go into the inventory for the player now, we see it also happens here, but this is not supposed to allow selecting of slots. So we'll fix that in a moment as well. But we can now select a few items and buy them, and only when the item slot runs out will it actually deselect the slot. So that is quite nice. So in this branching node, we also want to check if allow select for the grid itself is enabled. So we just make this into an AND boolean instead. That way it doesn't impact our normal inventory anymore, but it does impact our shop inventory. So now in the game, if I open up my inventory, you can see it no longer does it here, but if I open up the shop, it still does it there. Now, the very last thing that you might want to do is if you are running into a issue, and this is just fixing a couple of little bugs, where this thing does seem to be selected at first, but you can't increase the amount, which you will see in a moment here. If I buy this and I try to increase the amount on this side, it's not letting me because it shows it to be selected, but it actually isn't quite selected yet. And that might be an issue. It's easy to fix, just clicking on it, I will make it actually selected, and you can just buy and sell all you like, but that can be a little bit annoying, and of course you don't want that in your game. So at the very end of our event construct, we have our update item grids. To that, we're also simply going to add all of the events that we're binding to these event dispatches here. So that is update event buy, update event sell, update selected buy, and update selected sell. So if we just add those to the end here, so updates buy, updates sell, and then on new slot selected buy and new slot selected sell. Once you've added all of those to the end as well, that bug now also should be fixed. So we can open up this chest and immediately start buying things without having to double select things and just have it be a little bit messy. And honestly, if we're doing that, coming down here to the buy and sell buttons, what we can just do is at the very end of the function itself, what we simply want to do is we can just update item grids. So that way it just updates both of them anyway. Just makes things a little bit more compact and a little easier to deal with. So now we can immediately start buying these things, and then we can also immediately start selling them back without having to do weird double selecting stuff and all that. We have a functioning shop now. So again, I'm going to clean up a lot of the blueprint for this, and then it will be up for download. For you guys, it has been up for download since the first episode because I'm recording this way in advance. I hope this has been helpful. I hope you've learned a thing or two, and I'm going to start working on the next big series after this. So if you want to support that and get access, of course, to all of the project files, you can down below subscribe to the Patreon or become a YouTube member and get access to all that and support me at the same time. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,